Hey everybody, tonight we're debating flat earth versus globe earth, and we are starting right now with MCToon's opening statement. Thanks so much for being with us, MCToon. The floor is all yours.
Oh, well, thank you very much. Glad to see Austin and Kai here with myself and Carissa. Austin, when you're through Minneapolis, I'm sorry we didn't connect. That would have been fun, but glad to be here. So I have a presentation here. I'm gonna send to you right here. All right. So let me know when you got that and people are seeing it, and I will. I'll go through it. All right. So what I'm showing is a test, a measurement to see if the Earth is flat or spherical, and it uses absolutely no assumptions, and that's the cool thing about this particular one. So there's just a small amount of math to start. Fortunately, you don't even need to do any equations to do it. On the surface of a sphere, a triangle always has more than 180 degrees. On the surface of a plane, a triangle always has 180 degrees exactly. So if the Earth is flat, then any measured triangle, every one of them will be 180 degrees. And if the Earth is round or spherical, a sufficiently large triangle so that the measurement, the precision of the measurement instruments can resolve it, there will be more than 180 degrees in any triangle. There are no assumptions in this at all, nothing. So right there is just a little description of how it's done. It's called, the amount over 180 degrees is called spherical excess. So if there's any spherical excess, then you know that the Earth is not flat. And here's a little more. This is on my website at mctoon.net/se. All of this stuff is on there. So all my data is cited there. This shows a little bit with how the triangles work. Since the triangles are not in the same plane on the surface of a sphere, the angles are greater than 180 degrees. So there was a survey. It was published in 1900. It's a 900-page survey. It's called the Transcontinental Triangulation of the American Arc of the Parallel. I sent this to Austin more than a year ago, so he's had plenty of time to see it, to review it, to read it, to become familiar with it. I'm sure he has. They used these theodolites. These are 20-inch long theodolites, very, very precise, better than 1 arc-second of precision in this. In order to sight them, they set up temporary housing, temporary viewing stations on mountaintops, especially across the Rockies. And they use what's called a heliotrope on the ones that are being sighted. So one person's on a mountaintop with a theodolite, and then there's several people at different mountaintops with heliotropes shining these mirrors on the top toward the other place so that they can sight the different locations. So they have a shiny point to measure towards. Here's somebody using a heliotrope. You can see there's a telescope on it so that they can view the person with the theodolite who is measuring the angles. Now, you may be wondering, how did they deal with refraction? And that is an important issue. It is covered in there in the book, the survey. The thing is about horizontal measurements or azimuthal measurements is refraction does not affect it. It does affect zenith measurements a lot, but it does not affect horizontal measurements. So they go over that in the book. And the way that you do get variations due to potential atmospheric effects dealt with is you take lots of measurements, lots and lots of measurements. They take huge numbers of measurements. They get a really tight standard deviation so that they know that the measurements are very accurate. So I want to focus on just one particular triangle to begin with. And you can see right here, it is Mount Loma, Mount Diablo, and Mount Helena, which are in Utah, Nevada, and California. They have the observed angles right there, 28 degrees, 49 arc minutes, 8.348 arc seconds. The important thing there is that little number at the bottom, 57.778. That is the spherical excess. That is the amount over 180 degrees that triangle summed to. There are no assumptions in this. It is just a horizontal measurement of these three angles from these three mountaintops, nothing more. it sums to more than 180 degrees. Therefore, the Earth cannot be flat. Now, the thing is, there are hundreds and hundreds of these triangles in this particular survey, just this particular survey. And I have 5 others linked on my website at mctoon.net/SE. You can see here, 50 degrees, 50, these are arc, and it's over. So that is right there what I would ask anybody to explain. If the Earth is flat, how come all of these triangles do not sum up to 180 degrees? And if you think there's any assumptions in here, please be very specific in what you think they are. So that's mine. Thank you.
Thank you, Melvin. Is it good for me to go, James?
Absolutely.
Perfect. So I think there are many scientific reasons for the Earth being round, but there are also many ways that we can observe the Earth being round just by using our eyes, using our senses. And that is why even before Christ, right, in 200 BC, Aristophanes actually measured the circumference of the Earth. He used the sun. There were many, it was very accepted even over 2,000 years ago. And there are so many things that we can actually just see and visualize and experience that will lend itself to a spherical Earth. So some of those things that we can see on a day-to-day basis currently is that for lunar eclipses, we see them at many locations of the Earth. And if you see a spherical or a circular shadow at many different angles, that means that the whatever you're looking at, the shadow of whatever you're seeing is spherical, right? There's also other things that point very clearly to a spherical Earth, such as consistency of the stars. In the northern and the southern hemisphere, Polaris is constant in the northern hemisphere, and you see the other stars rotating around Polaris from our vantage point. Similarly, we see that in the Southern Cross. And also there's some things that it would not add up. So we also see the same face of the moon wherever we are, right? And that would not be possible if we were on a flat plane. So for example, if we were on a flat plane, if the moon was spherical, then someone very far away would see a different face of the moon than someone beneath the moon. Or if the moon was a disk, then it would not look circular. It would be distorted depending on where you were on the Earth. So there are many inconsistencies with a flat Earth model that can be observed just by the naked eye. You don't have to know a lot of science. You don't have to understand all of the mathematics behind it. These are things that are very demonstrable. And those are just to name a few. There's so many things that prove that the Earth is spherical. But that's all I have, and I'm excited to hear the opposing perspective.
You got it. Thank you very much, Carissa. And want to let you know, folks, if it's your first time here at Modern Day Debate, we are a neutral platform hosting debates on science, religion, and politics, and we hope you feel welcome no matter what walk of life you are from. Also, want to let you know, folks, if you have not heard, we are absolutely pumped for this upcoming debate next weekend between Apostate Prophet and Stewart on Christianity versus atheism. You don't want to miss it. Hit that subscribe button, folks, as we have many more juicy debates coming up. And with that, thanks so much, Wittsit and Ky, for being here. The floor is all yours.
What up? This is the beautiful Ky.
Hello.
And I am Wittsit Ky. All right, I'm going to try to share screen here. Maybe this will work. We shall see. Can you see it?
Yep.
Exciting. All right, we put this together really fast, but the Earth is flat. Don't make this weird, bro. We didn't lie about it. So anyway. So we're curious as to which one of these is the real curve of the Earth. Is it when we're at 100 feet? Or 10,000 feet, or 33,000 feet, or 7,000 feet, or 128,000 feet, or 1,000,000 feet? Which one's the real curve? Which one isn't the real curve? The crickets every time. So once again, here's the fisheye of the infamous Felix Baumgartner jump. And then this is a reality photo of a high altitude balloon, 121,000 feet. This is infamous astrophysicist, scientific communicator Neil deGrasse Tyson. Let's hear what he's got to say about it. Hopefully the audio works.
And that dude who jumped out of a perfectly good balloon, what's his name? Felix Baumgartner. He would have been about 2 millimeters above the surface of this globe. That's his edge of space jump. Now, you know, I don't, it's he wants to, I don't have a problem if he does it, but the honesty of it would greatly diminish what I think people thought he was actually doing. And not only that, they made sure to photograph him standing there with a really wide angle lens, which curves horizontal lines. So in the photo, you see this curvature of Earth's surface, and he said, wow, he's in space, look at that. No, he's not. At that height, you don't see the curvature of the Earth if you are 2 millimeters above this beach ball. You just don't. That stuff is flat.
Interesting. Of course, the globe earthers literally throw this guy under the bus. They act like he's a complete moron, propped up astrophysicist, shown to the whole world. They have no choice but to throw him under the bus, which should be pretty telling, but let's proceed. So here's this infamous billionaire goes to space launch, right? And it shows you this crazy curvature. Then a little bit later, I took a screenshot. I guess the Earth went convex and then concave. It can't make up its mind. So very interesting. And then here's your boy Neil deGrasse Tyson talking about this as people ran their victory laps because we've been to space, you stupid flat earthers. People are privately going there now.
Oh, by the way, you didn't ask, but I'm going to tell you. Do you know how high up above the Earth he was?
No.
So if you take a
63 miles.
Oh, yeah, right. So take a schoolroom globe, and that's how high above it is he? So he's about 2 millimeters above the surface of a schoolroom globe. So nobody's seen the curvature of the Earth from that height. I just want to make that clear.
Interesting. So no, you don't see the curvature according to this astrophysicist here from a plane. You don't see it from 128,000 feet. You don't even see it from 63 miles in the air. 63 miles. But why do they show this beautiful curvature here? And then of course you see that it's obviously not always curved. It curves up too. Doesn't matter. We'll just throw this guy up. So here we go with the infamous blue marble picture, right? Robert Simmons is the artist. This is for the people maybe unfamiliar with it. Here's a quote. We put it up here for you. Then we wrapped a flat map around the ball. My part was integrating the surface, clouds and oceans to match people's expectation of how Earth looks from space. The ball became the famous blue marble. So it's not a real picture. It was the default picture on the iPhone. But again, they're showing all these fake pictures of curvature, but it's probably because they're telling the truth. Here's all the different pictures of the Earth, and I guess the Earth changes from year to year. They can't figure out it has bipolar.
The size of the continents are changing.
The colors change.
Yep.
You know, well, we're crazy. You got to believe that these are real, or you are a conspiracy theorist. I like this.
Okay, so again, they say that the Earth is a ball. One main proof that they have is things disappearing behind the curvature of the Earth. So they use like sunsets or ships disappearing over the horizon as evidence that the Earth is a ball. But you can see here that things in the distance converge with the horizon. You can see with the street lamps, the farther the street lamps are from you, they begin to merge with the horizon. It almost looks like the street lamps are setting. You can see the hallway as well. The further distance, it merges with the horizon. We have a couple pictures, a couple videos. The first video we have is a boat. So again, they'll say, oh, the ship is disappearing behind the curvature of the Earth. When you zoom into the boat, you can see it again. So it's not actually disappearing behind anything, because if it was being physically obstructed, then you couldn't zoom in with the camera. Just like you can't use a camera to see through a brick wall or a mountain, you can't have a camera see through a hump of Earth curvature. So the real reason that boats are disappearing is not behind the curve of the Earth, but simply it's just leaving your field of vision. We also have another video here. This explains how sunsets are working on a flat Earth. as the laser gets further away, it's not going behind anything. It's on a flat surface. It's just leaving your field of vision as it gets farther and farther from you. And that explains how a sunset works on the flat Earth.
Yeah, which of course they say, no, there's no way it wouldn't disappear from the bottom up. There's a laser doing it. So the second law of thermodynamics dictates pressure will fill the available space, spontaneously seeking equilibrium. This is, of course, a natural law, not a theory, not debatable. The globe Earth belief system loves to hand wave dismiss the second law as if it's flexible or they can make it up or whatever. But here, I'll let you commentate this. But here's a little demonstration of the very simplistic idea of gas filling the available space.
So you can see here gas inside a vacuum chamber fills the available space. And then once
If you're able to just, it's really, I think that they maybe won't be able to hear you while the music's going simultaneously.
All right, my bad. I turned it down. Here you go.
You got it. Go ahead.
Okay, so the second law of thermodynamics describes entropy, high pressure going to low pressure. You can see here that also that gas fills the available space. Inside a vacuum chamber, the gas is still filling the available space. And then once the lid of the vacuum chamber is removed, you'll see that the high pressure in the vacuum chamber fills the available space, which is the surrounding air. The reason this is relevant is because we know we have gas pressure here on Earth, and they tell us that outer space is a vacuum. And they also say that the atmosphere is uncontained. So if the atmosphere is uncontained, then the high pressure here on Earth should fill the available space, and it doesn't.
Yeah, and just to make it worse, it's really funny that people laugh, but this is not even remotely close to the pressure differential of the 10 to the negative 17th torr vacuum of space people float around in. So this is hilarious that you think that something could be drastically greater with the pressure differential and just sit there chilling, going numerous different vectors, and pressure never fills the available space. The second law gets thrown out the window, but no big deal. Who needs natural law? We have cartoons. So here's the government telling you numerous times that the only way they can do anything with practical use cases when people's lives are at stake is to assume the Earth is flat. But the government's probably trolling with documents that had to be declassified and no one's ever read and they've hidden from the public. They're just trolling. They're just bored. Right here, propagation of electromagnetic fields over a flat Earth. This is actually how they engineer a ground weapon system, ground weapon towers, and they had to assume the Earth was specifically a dielectric plane in order for them to acquire the target or to have any accuracy of practical use. Here you go. They're talking about determining the brightness of the firmament, assuming a near sun and a flat Earth, and that the approximation for the firmament was proven correct in the bottom left. And of course, here we have the air trajectory model. The only way you can even design an aircraft is to assume the Earth's a flat, non-rotating surface, as do pilots when they fly them, where people would literally die. They don't assume that the Earth is curving down beneath them or spinning because literally they couldn't fly the plane. So there's numerous government documents. Here's just a couple of them we put together for you, saying that literally anytime that they design any technology or any practical use is used in the real world, the only way it works is to assume the Earth is flat, including electromagnetic propagation for ground weapon systems. Well, no big deal. Probably is a ball. They just have to act like it isn't a ball. Just a coincidence. So here's an infamous picture from 275 miles away, the infamous world's longest photograph. There should be numerous miles of obstruction here, like numerous feet of obstruction here, but it's not there. We just see the mountains and they must not actually be there. They're just where they are. Here are numerous states, science. Several U.S. states led by Florida are flatter than a pancake. There's like a list of 11 or 12 there. 10 flattest places on the Earth. You got all kinds of different places that are incredibly flat for immense amounts of distances. But the Earth is a globe. Obviously, it's just flat everywhere for hundreds of miles everywhere. And they admit it, and this is coming from physical empirical measurement, unlike McToon's little look at something in the distance and presuppose spherical excess, but we'll get into that later, I'm sure. So anyway, the Earth is such a ball that it's flat everywhere. You know how it goes. Okay, you can do this.
Again, on the globe model, the horizon has to be physical. But as you can see with atmospheric refraction, the horizon isn't physical. It's just the apparent location where the sky meets the ground. And you can see throughout the day, the atmospheric refraction changes. And it just confirms again that the horizon is not the curve of the Earth. It's just an apparent location.
Yep. The globe Earth has asthma. So it's breathing in and out here. This is the curvature rate of the Earth, right? So like as we invoke this, people get triggered. This is the globe Earth math, bro. Like the Earth is flat. Don't make this weird. We didn't lie about it. This is what they said we live on, bro. You can test it. It's geometry. There has to be a physical horizon. That's what geometry says, right? So this is the math. This isn't the flat earthers math. It's funny that we weren't taught this in school. No one knows what it is. I go around the entire United States. No one knows anything about the curvature rate or how to test it. We weren't taught that. We were just told there's a ball. And then, you could just be in the majority, make fun of the other side, and that makes them dumb. But good.
And so this is based on, so they told us that the radius is 3,959 miles, which means that the drop rate will be 8 inches per mile squared, I believe up to 1,000 miles.
Mm-hmm.
So you can see here in the chart, obviously the first mile, there's an 8-inch drop, but as you get further on, for example, 100 miles across, there should be a 6,666 foot drop. So if this curvature rate is real, if the globe is actually real, you should be able to easily detect this, and they can't.
Nope, nowhere other than looking at refracted images, assuming it's physical. So, and here you guys have probably, hopefully seen it, the infamous black swan observation. So for those that don't know, the reason it's called a black swan is because if you say all swans are white, and then you find a black swan, that nullifies or falsifies the notion that they're all whites. You just have to find one black swan. Then your statement that all swans are white isn't true, right? This is the globe Earth's black swan. That means when people run away, they just parrot the word refraction, which we can definitely get into the depths of it, right? It doesn't change anything. If this happens one time, the radius is wrong. Right? We have one in Australia right here, the observer height 5 feet. So it should be at 2.35 miles. The horizon's over 7.8 miles. So we'll go through it just for people that are new to it, right? So it's the modus tollens argument. If P, then Q, not Q, therefore not P. It's just a falsification, proposal, right? So if the Earth has a radius of 3,959 miles, every single horizon distance measurement must be no more than 1.225 times the square root of the observer's height in feet. It has to be. This is geometry based on the radius of 3,959 miles. Right, we have the observation on California right here, 1 foot off the surface of the Earth, and actually even less than that. And the horizon is beyond platform habitat, the furthest oil rig, which is 9.4 miles away. This would require the radius of the Earth be 264,000 miles. It's literally impossible. The physical curvature of the Earth that should block the observer's view should be before this still shot's even taken from the video, much further ahead, but it's not, right? So we have two black swans right here. There are all kinds of them. We just threw a couple on here. This can't be recovered from. It's been out there for a year. We still haven't had a sufficient answer. People just hear a word. They're told to say the word, but we're just here to open up the mind of the third-party viewer that's honest. If you don't want to know the truth, it's maybe flat Earth's not for you, bro. And then we have an infrared picture here.
10 more seconds left.
The furthest mountain is 255 miles away. Of course, should be blocked by over a mile curvature in the back from the top of the mountain, but no, it's just magically we saw through it. X-ray Superman. Here's your boy.
I can go to the moon in a nanosecond.
Time.
The problem is we don't have
That is just a bit over 12 minutes.
Oh, okay. Cool. No worries. Everything NASA shows you is fake. It's stupid. They're just bouncing around. You get it.
You got it. Thank you very much, both Wittsit and Ky. We appreciate it. We are going to kick it into open conversation, and then after that, we of course have Q&A. Folks, if you happen to have a question, feel free to fire it into the old live chat. If you tag me with @ModernDayDebate, that makes it easier for me to see your question. And then Super Chat is also obviously a way you can ask a question or make a comment, and we read those first just to get through them quickly, and then we'll jump into open conversation right now. Thanks, everybody.
All right. Hey, I'm wondering, why didn't you look up, Austin, what the actual source was for the 1.22 times feet in height? Why didn't you look that? A couple months ago, I asked you where Quantum Eraser got that, and you didn't answer me. Don't worry about it. Here's the deal. Let me share this because I want people to see. I know where he got it from. He got it from Andrew Young,
the subject matter expert. Andrew Thomas Young, our favorite guy.
That's who he got it from. This is the page that he lifted it from, right? Is this being shared? Okay. So you see right here, this is the no refraction part of the page, right? And right here, 1.23 or 1.225, he rounded up, times the square root of the eye height in feet. That's where quantum eraser got it from. Okay. That is, again, from Andrew Thomas Young, Quantum Eraser Loves the Sky.
Andrew Thomas Young, San Diego State University, Astronomy Department. So, Andrew Thomas Young, San Diego State University, Astronomy Department, the subject matter expert.
The subject matter expert. Excellent. So the problem is that Quantum Eraser stopped reading at this point, and he does not read on to where Andrew Thomas Young talks about refraction in measuring the distance to the horizon. And that's the crucial point of your black swan image there, is that there's no refraction. That's the most important part of that. There's no refraction involved. Yet Andrew Thomas Young, the source of that formula from Quantum Eraser, talks about refraction in detail. Look at the rest of this page. That page is significantly longer than just this first part that Quantum Eraser likes to look at. Now, okay, Austin, I know that you love demanding that refraction happen.
Refraction, which we immediately and adamantly claim is always present because there's temperature fluctuation and atmospheric conditions that are consistently affecting what you perceive.
I completely agree. So be sure, Austin, in your analysis to include refraction, or I will just play this.
Refraction always happens
over and over again.
It's important.
Okay.
All right. You're done? Okay. He didn't get it from Andrew Thomas Young, my man, right? It comes from...
So, Andrew Thomas Young, San Diego State University, Astronomy Department.
Yes, he did.
Subject matter expert.
That's where he got it from.
Dude, we heard it, bro. You took
that's where he got it from.
Calm down, man. Calm down. All right.
Be sure to include refraction in your analysis.
My man is tripping. All right. It actually comes from geometry. It's the radius value of 3,959 miles. That's where the number comes from. Now, of course,
but you didn't include refraction in your analysis.
Refraction increases proportionate to the distance.
Are you done?
Oh, yeah, go ahead.
Let's give the same way that we gave you several minutes. Let's be fair and give the same to Wittsit.
All right.
Okay, so 1.225 times the square root of the observer's height in feet comes from geometry. Whenever quantum invokes Andrew Thomas Young is because it's the subject matter expert for your side, right? So we have many people run around act as if that number's wrong or something. He's like, look, even the guy on your side agrees. Okay, so the number doesn't come from Andrew Thomas Young. He didn't create the equation, which is what you're insinuating. It's literally geometry, okay? It's not debatable anyway. But when you bring up refraction, right, you should go back to your little page and you should see the formula. We should enlighten everyone what it is. It's 7/6R, R being the radius of the Earth. So you actually have to know an accurate radius value, fluctuate it in theory, not in reality, of course. The Earth isn't fluctuating. You know what I'm saying? It isn't actually increasing by 15%, is it, MCToon? No, it's just theoretical to explain this rate we need if the Earth's in fact a ball. So you actually have to reify the R value that's being contended and falsified, and then you have to extend it and then say, look, this formula proves it.
But I don't use that particular measurement or observation to measure the radius of the Earth. That's done external to that particular measurement. It's already known what the radius is. But no, it doesn't matter. You cannot look at that photograph without including refraction in the analysis.
And never the radius dissecting of the observations, you even account for refraction that we know for a fact to be present.
Absolutely.
Bro, does the radius change? Like when you put 7/6R, can you change the radius?
No, but refraction changes what you see.
When you just throw refraction out entirely, invoking the furthest point away in the image and saying that you don't have to account for refraction and making the baseless assertion it doesn't move it because you showed us some really not very great images where they look to be generally the same is laughable, bro.
That's laughable, bro. No, include the refraction in your analysis, bro.
Okay, so, bro, my friend, I'm asking you, can the radius change? And if it can't,
if you're not going to include refraction in your analysis, don't bother.
I'm claiming that you haven't even actually accounted for all the variables and you're touting your trigonometry that literally hand waves dismiss one of the most important variables when it comes to perception, which is refraction.
I couldn't say it better myself. Go ahead.
Okay. Once again, bro, you can't actually fluctuate the R value. So they give this theoretical equation to explain how
I'm sorry. You yourself demand that refraction be included in the analysis. So include refraction in your analysis. Go ahead.
Okay, no problem. The horizon is nothing more than an apparent location that fluctuates based on atmospheric conditions, including refraction and the observer's heights. right? So it constantly fluctuates. You're making an additional claim. You're actually claiming it's a physical, actual location based on.
I didn't claim. But this is your picture, not mine.
So do boats go over the curvature of the earth, McToon?
Absolutely, they do get obstructed.
You do claim it's physical. Yeah. Thank you, man. Thank you for just contradicting yourself instantaneously. So if the earth is a radius value of 3,959 miles, there's a physical obstruction. Flat Earth knows that the horizon is just apparent, constantly fluctuates. We showed that. I don't know if you were paying attention to the presentation. We actually showed a time lapse where the horizon constantly moves.
Absolutely, yeah. That's why you need to include refraction analysis.
But if your refraction,
you made my point.
If it requires the reification of the R value in contention, it is inadmissible, my friend.
No. The radius of the Earth was measured external to that particular observation.
So it doesn't use the horizon.
When the measurements for the radius that I cite do not use the horizon. No.
Right. It uses stuff like we can presuppose the distance of the sun, and then we can come up with some correlative response.
No.
Yeah.
I will happily show you how to measure the radius of the Earth.
Okay, but can we hone in on one thing for the audience, because some people are new to this conversation? Do you agree that on a ball, there has to be a physical curve that will block your view and you can't see past it?
Yes, a physical curve that is affected by refraction. So you must include refraction in your analysis. So anytime you do this, be sure, according to you, because you demand that refraction be included, be sure to include refraction in your analysis.
Okay, once again,
that's all I'm asking. Hold on. I think what we're missing here is that radius is constant and refraction is a variable. So that might help you in answering Melvin.
No. What will help me is if you know what the subject matter expert says, which is that you have to invoke terrestrial refraction and fluctuate the hypothetical R value to 7/6 stars just to get an idea of it. Then you must, in fact, invoke and reify the idea of light rays, which are just an unrealistic concept. This is all coming from the subject matter expert. And then you didn't have to ignore the fact there is no horizontal boundary. So you must assume the Earth's a sphere, assume the R value, fluctuate it hypothetically, which is a category error because you're talking about light over top of the Earth, not the Earth's terrain itself changing. And then you have to invoke light rays, which aren't real. That's what the subject matter expert says. So we're actually
the R value. Here's the deal. According to your own demands, you've still not included the refraction analysis. I'm just waiting for that. Go ahead.
The horizon's just an apparent location that.
Okay, but if you're gonna bring up an image that obviously has heavy refraction in it, be sure to include analysis of refraction in the analysis. Here, go ahead.
So you agree then that we always have to account for refraction when we look at the horizon?
It should be, yeah. Definitely.
Okay, so then you can never actually see the literal curvature of the Earth then, right?
Everything we see goes through a medium. So everything we see is modified by that medium. So you just need to control for those conflating variables.
So we can never see the actual curvature of the Earth then, right?
You can never see anything that is just unmodified by the medium through which the light travels.
So we can never see the actual curvature of the Earth then, right?
You can never see actually anything because everything is different. Are you that stupid that you don't understand that if there's a medium, there's a medium?
Live on a ball, okay? For example, a pregnant lady's stomach, right? When she's 9 months pregnant, her belly physically obstructs her ability to see her feet, right? Okay, but you're saying that on in your reality, you can never ever see this curvature of the Earth. Now you say that boats are
see it unmodified.
You're saying that
so
boats
stop
are
strawmanning me.
Are you
can never see it?
No,
because you're strawmanning me. I'm not gonna sit here and let you strawman.
You're making contradicting statements.
Here's the deal. Everything you see is modified by the medium through which the light travels. You just need to take into account these modifications.
Okay.
So we never
be sure to do that. According to you.
I'm claiming that you haven't even actually accounted for all the variables, and you're touting your trigonometry that literally hand waves dismiss one of the most important variables when it comes to perception, which is refraction.
Go ahead.
Are you promoting my channel, bro?
Include your own declaration that it's the most important variable. Go ahead. Include it in your analysis. If you don't, then you are contradicting yourself.
It's the most important variable because the horizon is an apparent location. You're claiming it's a physical location. You claim that boats go over it. So you now have to admit intrinsically within your contradictory little worldview crafted to you by Jesuit priests that you never see the curvature of the Earth. That's what
you never see it unmodified. Everything is subjected to the modification of the medium you see it through.
So if we never see the curvature of the Earth,
so
how do we know it's there?
You need to, because you can then account for those changes because we know how it affects our vision. So you can account for those changes.
So we have to assume that it's there. We never see it's there, but we have to assume it's there and then make up math to explain why we don't see it.
Just all you need to do is control conflating variables. That's classic science stuff. If you don't like doing it, I understand, because it gives you the result that you don't like.
We won't get into that. You don't know what science is, man, but you agree that you don't see the curvature of the earth, right?
You don't see anything unmodified.
Right. So if you never see the actual curvature of the earth, how do you know it's there, McToon?
Because you can control for conflating variables.
Like the atmosphere?
Yes.
You can, absolutely.
You can control the atmosphere?
Yeah, you remove the atmosphere?
No, you
deep,
can.
Man.
No, I'm sorry. You don't understand how controlling conflating variables works.
No, please enlighten me how you control the atmospheric refraction.
You don't control it. You measure it, you quantify it, you figure out how it is affecting your observations, and then you include it in the analysis.
So you presuppose there is a curvature that you don't actually see.
No, you are not presupposing curvature. You are using the known effects of refraction.
Okay, and you're saying we never see the actual location of curvature, but since we know that there's
you only see modified things, Austin. We stop strawmanning me. You only see a modified view of everything. So when you do science, you need to. It's called controlling conflating variables. You take them into account. So if you know that refraction is happening, then you include that in your analysis. And if you don't know much about the refraction that's happening, then you don't have a very good observation.
Okay, so just to make sure that the audience knows, usually when you're on the side that's objectively right, and there's this other fringe group of people that are just really stupid and crazy, you don't have to constantly interrupt them, including females. Just a side note. But my point here is,
if you're going to straw man
identity politics, your identity politics. What is it with his id poll? Aren't you like what the heck?
Wow,
he's like literally explaining you like the science, like how to actually. You're saying that like controlled studies, you actually have to like control whatever variable. What? No, you have to measure with it. You have to measure. You have to see the effect of it, and you have to like take that into account. That's all he's saying. And you are 100% strawmanning him.
No, I don't think you understand the argument, Carissa. This is the issue. Is you said with
you literally said you don't think that we can see the horizon.
Go ahead, girl.
The audience is gonna see you guys are imploding.
You're interrupting. Let me know what you're. I'm sorry. That's too funny.
Can she talk yet? Can she talk yet? Is it her turn yet? Can she talk? Thank you.
Okay. It was just too funny.
No, thank you. Okay, so I don't think you necessarily understand the issue. As you said earlier, that with our senses, right, we can know that the Earth is a sphere. Here's the problem: there's a claim that the Earth is a certain size and there's a certain radius value.
Of
and
course.
If it's so obvious that this curvature exists, then we have to be able to measure it and detect it, okay?
Yes.
But here's what McToon is saying. McToon is saying that you can never actually observe the curvature of the Earth because of refraction.
That is false, because we can measure refraction and we can control for
so if we never actually see the curvature of the Earth, how do we establish that it's there?
So we can see the curvature, but it is as you were saying, a modified view. We can see it changing. You are interrupting a woman.
Yeah, somebody just interrupted a woman.
You're seeing the change of the curvature to an extent, and that's because of the refraction. But just because you see changes in it and illusions doesn't mean that the curvature itself is not there, right? So like if it's nighttime, and you know that there's a tree, where somewhere, and you're like, oh, I know that there's a tree there, and if you like shine a light there, you're like, okay, so how do you know? Because you didn't actually see it without a light. You're controlling for the darkness, which is a variable, by using a light. It's the same type of thing, that there's a variable that's impeding your measurements. So you measure that variable, and then you're able to take it away and have an actual accurate mesurement.
But terrible analogy, Carissa, because we don't know the tree's there. That's what's in contention. Is there curvature there?
No, we know that there exists a horizon to an extent, right? You have to there's a separation between earth and sky, right? Do you believe that there's at least at some point a separation between earth and sky?
Watch our PowerPoint.
Do you not pay attention?
So you think that it's the same thing? Of course, there's going to be a difference.
The definition of the horizon is the apparent location where the sky meets the ground.
Correct.
The apparent location. But in the heliocentric model with the globe, the horizon is actually a physical location. Like I brought up with the analogy of the pregnant lady's belly, that it's a physical curve that's there. If it's an apparent location, it can't change. And it can't change in distance.
If it's physical.
Horizon is purely, so, okay, we can see the curvature of the earth, and you're right that itself is static. We can see it through the medium of, there's heat refracting off the earth. There's many things happening that might distort our view of the horizon. But horizon itself, everyone's going to see a different horizon because people are at different locations, right?
But that's
so you can't necessarily say that like, oh, there is one definite, of course, all horizons are based on your perception. That's the way horizons work.
But see, Carissa, that's our argument.
But that doesn't mean that it doesn't exist.
The globe argument is that boats and ships and the sun is disappearing behind a physical location.
And it's interesting.
But now you're
from
saying
the bottom
that you're saying so there's the ball is a specific size and it doesn't change, right?
Correct.
It doesn't change. Okay, it's 25,000 miles in circumference. It doesn't change. But what you're saying is that we're seeing the horizon change in distance. And that can't work if the horizon is a physical location.
Do you? It's not. Horizon is perception, and the Earth curve is physical. So when you look, when you see a horizon, you are viewing. Hold on, can you stop interrupting a woman? When you see a horizon,
that was pretty funny.
When you see a horizon, that is your perception of the static Earth's curve. So. It's going to be there's going to be some variables within that curve, right? That's affecting it and affecting your perception. We don't have like telescopic vision, and similarly, there are some elements. There's gases in the atmosphere. I'm sorry, that's just the way it is. But we can measure those things. We can measure effects that it has on our vision of the our vision, and then we can measure it and we can account for it, right? That's like literally how every single scientific study works, even if it's not observational.
Yeah, but let's just recap, right? Because what you've said like 3 times now is, well, that doesn't mean it's not there. Well, I've never seen Superman, Carissa. That doesn't mean he doesn't exist. What is that? Your argument is, even
why that straw man? That has nothing to do with it.
Yeah, she said just because you never actually see it, that doesn't mean it's not actually there. Well,
it means you can control. You can control for that variable. That's what you
control. No, you can't control the atmosphere.
That's not what she's saying. Don't straw man.
1 sec. All right, just to have order. Remember, folks, all 4 of you, people are excited to hear your ideas, and so we just want to be sure that there's not too much interrupting. So what we'll do is give you a quick chance to respond, Wittsit, maybe a minute or 2, and then we'll come back to Carissa and MCToon for a minute or 2 as well.
Thank you, man. So like what her analogy was, you don't see the tree, but you know there's a tree there. Well, we don't know the curve's there. Hence why we're here. The Earth's flat, bro. Don't make this weird. Okay. We're trying to figure out if the curve is there. We don't know it's there. We're trying to find out if it's actually there. And then you shine a flashlight on the tree. So you control for the variable of it being dark, and then you can see it. Well, you don't get to control the variable of atmospheric refraction now, do you? You don't get to shine a flashlight and see if it's there. The atmospheric refraction is outside of your control. It's just there. You actually try to measure different variables within it, presuppose a certain radius value, a certain curvature rate, and then a differential in the optics of what you actually perceive. That's why it isn't analogous. She continuously says, well, just because you don't see it doesn't mean it doesn't exist. And that's why I said, well, I've never seen Superman. I guess that doesn't mean he doesn't exist either. We need physical empirical measurement, and we need to know if we never see the curvature of the Earth, how do we know that it exists? It's very simple.
Well, I gave you a physical empirical measurement.
Okay, so you want to move on to that. You concede that optically.
I don't concede. No. I concede that you did not include refraction in your analysis, which you demand must be done.
Yeah, we actually, in our presentation, we showed you a GIF. It says atmospheric refraction right below the GIF.
But you did not include atmospheric refraction analysis in that black swan image. As you demand, must be happening.
Right, but the difference.
So I concede that you contradicted yourself.
But McToon, the difference here is your analysis requires us assume the Earth is.
You need to do the analysis. It's your claim. You're claiming it. You should do the analysis, not me. You go ahead and provide the analysis, or be a hypocrite because you demand the analysis happen and don't do it.
Okay, just to clarify for the audience, right? Because there's some new listeners here.
I'm claiming that you haven't even actually accounted for all the variables, and you're touting your trigonometry that literally hand waves dismiss one of the most important variables when it comes to perception, which is refraction.
There you go.
All right, so just
be a hypocrite.
Just to clarify for the
hand
audience.
wave away refraction. Go ahead. Hand wave refraction. Be a hypocrite.
You're triggered, bro. This is weird. You're making it weird. You need one of my shirts.
Hand wave away refraction. Go ahead.
Calm down, man. Drink some water or something, bro. All right. So to clarify for the audience, okay, I'm not claiming that the Earth's a ball. You are. So what the flat Earth says is that the horizon is an apparent location. It just fluctuates based on atmospheric conditions. It's not an actual place. It's just optics, right? When we showed you the hallway, we showed you the railroads, we showed you the laser, right? It's optics, an optical convergence that isn't actual. And this is replicatable. It's very factual. That's what happens. The atmosphere changes where that looks like it's going on. It's an optical effect. You are claiming that there is a physical location there, but the atmosphere takes place, so we never see the actual physical location. You have the burden of proof to substantiate a physical location that we never see. I know that it isn't a physical location. So you need to explain how it is that we never see it. And so what you do is you reify the R value, fluctuate it, which is a category error. The R value doesn't change, MCToon. So you are.
I'm not claiming that it changes.
Sorry, man.
So don't straw man me. I didn't claim that the R value changes.
You do when you invoke terrestrial refraction in the.
No, I don't.
Do you not agree with Andrew Thomas Young then? Or you want to throw him under the bus?
He is not claiming that the radius value of the Earth changes either.
The equation utilizes 7/6R.
Yeah, it does that as a way to deal with the effects of refraction.
But is that analogous or is it a category error?
It is not a category error. It is a way to mathematically predict what you would see due to the effects of refraction.
By hypothetically fluctuating the actual size of the Earth.
It is not fluctuating the size of the Earth. It is affecting the radius of the ray of light. That's what it's doing.
The light is, the way that they come up with the rate is by putting 7/6R.
Yes, R, which has been measured.
Okay, so you agree it requires a reification and a fluctuation.
It's not a reification. The radius value has been measured. It's no reification. So don't straw man me by saying it's a reification.
Let me
I can provide for you many measurements of the radius of the Earth.
Right.
I have one based on the evidence that I provided earlier already.
And so this is pertinent to this to save us some time, okay? So like you agree, we don't see the actual curvature of the Earth, and that looking at the horizon due to fluctuation based on refraction isn't an adequate methodology to determine the R value, right? So when we go back to like say Al-Biruni, the first person attributed to getting the R value.
Don't straw man me. I didn't bring up Al-Biruni.
Which is why you should stop interrupting, because what I was about to say is then you would agree that isn't actually a sufficient method. So we can throw that one out. They taught us that, but he was actually using an insufficient method because
it doesn't matter. I didn't bring it up.
I know. I'm just saying.
Why are you straw manning me again?
How am I straw manning if I'm asking?
Because I didn't bring it up. You're trying to defeat Al-Biruni's measurement of the radius of the Earth, which I did not bring up.
No, I'm trying to help the audience that may be new to this conversation so that they will know that Al-Biruni is the one that's attributed to originally coming up with the R value. Whether or not you want to talk about him or not, it's irrelevant. We're doing this for people that actually want to know the truth, MCToon. The person attributed to coming up with the R value is Al-Biruni. He took a fluctuation of the horizon, made different measurements, and came up with an average, throwing out outliers that were too extreme of differential, correct? Yes, it is correct, MCToon. So for the audience, just so you know, the R value they taught us and the methodology, MCToon and all Globers now in the trenches have to admit is inaccurate. They have to throw it out because we never see the actual curvature of the Earth. I'm just making sure they understand that whenever you look at the horizon, that isn't the curvature of the Earth. You can't use that to come up with the R value. It constantly fluctuates at its apparent location. We've never seen the curvature of the Earth in actuality, but we can assume it's there and then come up with theoretical mathematical equations to explain why it's moving at a certain rate. That's objectively what you've said so far. I encourage the audience to rewind it and listen. Okay, we can move on. Unless you have some contention with my recap.
We also, in addition to MCToon, would love as well to hear from Carissa as well as Ky, as I know, don't get me wrong, I know that MCToon and Wittsit, you have a very personal history, but nonetheless, just to be sure that we get an equal distribution from everybody. Go ahead. Either of you, MCToon or Carissa.
If you don't mind, I think I would like to bring up, I think your black swan analogy was interesting, but I think it can also go the other way. Can you give me your visualization of how the map of the Earth would look?
So I understand why people would want a model, but we don't actually have the positive claim.
Okay.
So the positive, because you again, I'm going to bring up what you brought up is our senses. It's common sense that the Earth is a sphere. But we actually don't observe curvature. We don't observe axial rotation.
No, that's not what I'm asking. I'm asking.
No, I understand. I'm saying, but we don't have these positive claims. We just falsify the positive claims of the globe.
Okay,
so we can never know. We can
you
never
think it
know.
might be a square, or do you think it's actually flat?
No, we know
because your shirt has the positive claim of the Earth is flat. So you literally are making a positive claim. I'm just asking you to substantiate it.
We don't have the positive claim.
Your literal shirt is a positive claim.
Yeah.
Okay, so the globe has the positive claim because in our day-to-day reality, we observe the horizon, the horizontal horizon. We observe flat, stationary. You don't observe spinning 1,000 miles per hour. You don't observe gas pressure without a container.
So when you're in an airplane,
earlier when you cracked open your little soda can, you just demonstrated the second law of thermodynamics, okay? And the globe model argues against that. So you do have the positive claim. We don't have a model. We can never know what the actual Earth looks like. All we know is that 1, it measures flat. 2, it's stationary. And 3, there must be some kind of container because we have gas pressure. The definition of gas pressure has container in the definition. So we know that it's not an open system. The vacuum of space cannot exist.
Do you understand that a vacuum?
Long story short, we don't have a model.
Okay. Do you understand that a vacuum doesn't mean that it's sucking, correct?
Of course. It's just ultimate low pressure.
It's just nothing. There's nothing there. Vacuum is just nothing.
Pressure.
Well, there's no such thing as a perfect vacuum.
But you have space from the spherical Earth, the globe perspective has no particles in it, right? So, but the gravity, our Earth has. Do you believe in gravity?
Believe in gravity? Well,
yes.
Let's actually define gravity. Which type of gravity are you speaking?
A vector that has
there's
for this discussion is a force. It has a direction, and it has a magnitude. It's a vector. Do you believe in that?
For science, first of all, just for science, there should be no belief, right? That's kind of the antithesis.
Okay.
Antithesis of science. But what you're
talking about. Does gravity exist? Let me rephrase this for you. Does gravity exist, in your opinion?
Okay, my opinion is irrelevant, but let's go ahead. So you're talking right now about Newtonian gravity, which is mass attracting mass, which said that gravity is a force, okay? And he demonstrated that kind of like the way to think of Newtonian is like the apple falling from the tree, and it's falling to the ground because the mass of the Earth is pulling the weak mass of the apple. Well, that was actually superseded by Einstein. So now gravity, when you're talking about gravity, you're talking about the bending and warping of space-time. I can pull up some sources for you.
I understand that, but for this discussion, it can be viewed as a force. Just for just this contained discussion of what I'm asking. Do you think it has a magnitude?
Why?
And do you think it has direction? That's all I'm asking.
So we're here to debate the heliocentric model. If you're not fully educated on the heliocentric model,
I'm not saying it's a force. I'm saying it's acting as though a force. I'm saying it's acting as a force. Correct?
Gravity is not a force.
I understand that, but it's acting as a force. It's acting as a force.
It's not
correct.
It's gravity is the bending and warping of space-time.
Okay. Do you believe that there is a vector?
That there's a downward acceleration?
That has to do with some type of force-like component.
Obviously there's an observable downward acceleration, but here's the issue, is the established cause. You're saying that the heliocentric model says that the established cause is the bending and warping of space-time. Which they have failed to validate through the scientific method. There's no way that they can actually use a scientific method and verify the cause and effect relationship.
But we understand, so we can have very, very precise measurements of how fast something will fall, the density of things, and how so like in physics, we view gravity as like 9.8. It's literally viewed as a force to see things pulling down to a larger mass, as you said. And that's why I don't think you understand the gas situation. Of course, gas is going to be lighter than our atmospheric air, and that's going to dissipate, correct? But when there is something with no particles, then that gas, and that's why you see rain. That's literally why we see rain, is because water particles get so heavy and they condense together and they fall, correct? And that's because that's why literally gravity is like why we aren't going out into space, and that includes the gas. That includes literally everything that you brought up earlier.
So gravity affects gases?
Yes. Yep.
So helium, I see helium rising. What's happening?
Yes, because helium is lighter than the air around us, which is oxygen, nitrogen.
Right now, so right now density. You have two contradicting statements. Right now you have two contradicting statements. You're saying it's
no, I don't. I'm saying that our air that we are existing in has many particles in it. So if we have lighter particles, those lighter particles are going to rise until they are no longer lighter than the air surrounding it.
So density disequilibrium, you agree with us?
What are you talking about?
If the air is lighter than the surrounding air and it goes up, that's because of density. So you agree with us.
And when the air goes up, there's fewer particles, therefore it stops going up.
But why does it go up?
Because it's less dense than the surrounding air.
Oh, okay. So you agree with us. Yeah. So downward acceleration.
No, don't straw man again. Don't straw man again. You're just
you understand. Okay,
that's all you have. That's all you have is straw mans.
Believe is air. What is air in your opinion? Do you think it's
what
just
is void? Air?
Yes.
Air.
Do you think
we need to make it simple for you guys.
Okay, so here's the deal. We have downward acceleration on the Earth. It's an agreed upon average.
Oh my gosh.
Yeah, he can't just.
He can't just answer the question. It's ridiculous.
No, he can't. He just has.
What is air? That's your question.
Shotgun word salad. Yeah.
Is
There's a combination of different gas pressures that couldn't exist adjacent to a near perfect vacuum 10 to the negative 17 torr. Feel free to stop interrupting me.
Go ahead.
Now make sure you keep interrupting me. It'll make the Earth a ball. Dude. So we have an agreed upon average of 9.8 meters per second squared of an observed phenomena called downward acceleration on the Earth. Now this is just an agreed upon average for intents and purposes.
It's not agreed upon. It's measured.
Is it always exactly 9.8 meters per second squared?
No, but it's measured.
Okay, it's an agreed upon.
It's not agreed upon. It's not an agreed upon average. It's a measured average.
Okay.
You don't know what a measurement is? You don't know how to measure the downward acceleration? It's measured, not agreed upon. It's empirical.
Calm down, bro. So we have an agreed upon average of 9.8 meters per second squared downward acceleration on the Earth. That is the effects, of things falling. Not everything falls, as she just enlightened you. Helium goes up, and as your teammate has said, it's because of density alone. That's her explanation.
What is air?
Another straw man.
What is air? Tell me. The particles. Tell me the particles. What is air composed of?
Hey, calm down, Chris. Can I finish my point, please?
Can you answer my very simple question? It's elementary, maybe middle school. No, particles. I'm talking about particles. I'm talking about the elements.
Out of your league,
the table of elements. The table of elements. Just tell me, okay, if I'm out of my league, then please just answer my simple question.
Oh, what a dick.
Okay, calm down.
It's okay. It's okay.
It's okay. The Earth's not a globe, but don't make it weird for a sec. Okay? So look, we have an agreed upon average of 9.8 meters.
A measured average.
Okay, McToon, calm down. So that's just an effect, okay? It's just an effect. Downward acceleration. Gravity claims to be the causal agent of that. So when you invoke downward acceleration, cool story, bro. No flat earther says that some things don't fall to the ground. But actually, what you guys run around acting like is as if everything falls to the ground, even though things go antithetical to the singular vector down to the relative mass of the center of the Earth, right?
Of course they do, because they're lighter than the particles.
Welcome to flat Earth, Carissa.
No, it's welcome to 8th grade science class that we need to teach you again that you didn't pay attention to the first time. No,
see, we know that density disequilibrium results in different directionality.
Here's what you don't know. You don't know that multiple forces can act on the balloon at the same time.
No one said they
That's
couldn't.
what you
in
don't
theory.
know. No,
We're
you
asking
don't know
to
that.
prove-
You,
we're asking
you
to
think
prove
that
the
only
hypothetical.
you think that only one thing can act on the balloon at one time, and that
Straw man.
if it goes up, then gravity stopped acting on it. In fact,
Straw
both
man.
density, both buoyancy and gravity affect it at the same time. Just that the buoyancy is larger than the gravity, then it goes up.
It's larger. Okay, so stop interrupting, my man. Okay, so we know that relative density disequilibrium result in directionality. Helium and hydrogen are lighter than the surrounding air, so they go up. That's antithetical to the singular vector of down relative to the center of mass that gravity invokes. When you have downward acceleration, as Carissa was enlightening us stupid flat earthers about, that's just an agreed upon average of an effect, right? You're claiming the causal agents, right? Now you're claiming an additional force is present that hasn't been isolated. You haven't manipulated the variable of space and time bending and warping and dilating. You presuppose it, right? You presuppose the causal agent, seeing the effect and say, look, the effect proves my cause. I don't have to prove the cause, but you do. That's what's in contention, okay? So whenever the only thing you can empirically verify is the density relationship affects directionality, and that's what we say. I can actually get much more specific, and McToon, I can guarantee you, I'm trying to give you a heads up here. You're not ready, bro. Okay, so she already handled Carissa and you very sufficiently. Would you like to acknowledge that you don't have an empirical evidence of the bending and warping of space-time, which is the current rhetoric of the heliocentric model?
Not at all. Eddington, 1915.
1915 proved space and time bend and warp. Please enlighten us.
Eddington, 1915 was the first empirical confirmation of space-time bending.
When did they isolate space-time? How do you do that?
It was an I'm sorry, I'm not playing your you don't understand science game. Okay, it's a peer-reviewed, published experiment that Eddington did in 1915.
What did he do?
Confirming the bending of space-time.
How did he do that?
What did he do?
That was the eclipse of 1915.
Wow.
So he looked at the sky and proved that space and time bend and warp?
Okay, well, you
Was
go
he
ahead.
smart?
You go ahead and I'll just let you read it and
Isn't there a difference
probably
between
go over your head.
correlation and causation? Don't you learn that?
Almost
in,
as
like,
if
Stat
most people see the Earth, most intellectuals view the Earth as being a sphere. And
appeal to majority.
generally
Wow.
No, I'm not making that as an argument. I'm saying it's been empirically proven in 99.9995 of any academic sources that are going to tell you that.
I've not seen any academic sources saying otherwise at all.
Because they're censored and people will be fired. But anyway, her turn.
So hold on. I want to get back to my point. So I'm going to explain to you and to the audience what air is. So air is a collection of elements: nitrogen, oxygen, many others. And if you look at the periodic table, you see helium, and that is one of the lightest of the elements. Therefore, there is buoyancy and there's density. When something is lighter than other things, it will rise. But when it gets to a point in time where it is so high and there's not many other particles around it, then it will not rise any longer. Because it is heavier than the void, correct? Therefore, it stops rising because of gravity. Therefore, that is why all the particles on all the gases do not go all the way into space. It is really not that hard to understand. It just is how density and buoyancy and gravity interacts. And this is literally middle school stuff. So I don't understand why you have this smugness. It's like, oh my God, I can't even tell you what air is because I'm just so buff you. When you literally can't even answer a simple question. It's so sad.
Okay, thank you. Thank you for explaining that.
You're welcome.
No one is disagreeing. Flat earthers do not disagree with relative density. A great example.
Then you wouldn't have given your definition in the first place with the gas going up.
Okay,
Carissa.
no one is disagreeing with relative density. And also, we are not disagreeing with the downward acceleration. What we are disagreeing with is the cause of the downward acceleration. Okay?
It doesn't matter.
Yes, it
Carissa.
does. Yes, it does. Okay? So,
No, it doesn't.
yes, because you weren't even
That's not how-
educated
that's-
on the
that's not how law
cause.
works.
You weren't even, guys, I haven't talked very much. It's my turn to shine. Okay. So this is the thing. You want to say that the cause is the bending and warping of space-time. The cause absolutely matters, Carissa. You weren't even educated on your own model. It's not massive.
What are you talking about? I said it acted as a force. I never said it actually was a force.
What are you talking about?
That's a straw man.
Let me finish. So, okay. The cause, establishing the cause and effect, which is the whole purpose of the scientific method, okay? And what we want to know is how they actually established that it's the bending and warping of space-time. Now, McToon brought up an eclipse, and I have a question for McToon. McToon, what is the difference between correlation and causation? What is the difference?
Yeah, a correlation is not causation.
Okay, thank you. So how do we actually know then if we're observing, just observing, right? Observing, because there's no manipulation going into the eclipse, right? We're just observing. How do we actually know then? Because that's the key part of the scientific method, is manipulating the independent variable to establish causation. Just for the audience, a good example of correlation, the difference between correlation and causation is every time I see the sun rise, I hear a rooster crow. So therefore, the rooster crow is causing the sunrise. Right? We're observing two things happening at the same time, but that which is correlation. But to actually know that the rooster is causing the sunrise, we would have to manipulate the rooster, right? We'd have to take the rooster out of the equation. Oh, the sun still rises. Okay, it's not a causation. So when you're just observing, how is an observation establishing causation?
It wasn't just observing. They positioned themselves and waited to the appropriate time for the sun to position itself relative to the star.
Did they observe it?
Did they manipulate the sun and the stars?
No, they manipulated
so they
their
just
look.
observed. So
Hold on, I didn't finish what I was telling you that what they were manipulating. They were manipulating their position relative to the sun and the star so that they could see if it was bending around it or not.
I understand, but did they manipulate the sun and the stars?
No, they manipulated their position.
So they just manipulated where they were looking and observing.
Where yes, absolutely.
But the independent variable, which would be
space
and time, they did not manipulate. They just observed, correct?
The independent variable is not space and time.
Yes, it is.
Space. Sorry. First of all, there's no and between there. It's space time.
Sorry, space time.
Okay.
Space
Well,
time.
actually, it's made up of space and time, so I'll say the and.
Okay.
Anyway.
Sorry.
Okay.
So yeah, they here's the deal. You always go on about, because this you get from Quantum Eraser parroting him, that somehow this independent variable, dependent variable is absolutely required in an experiment. It is not actually. Your only source for that is Quantum Eraser, and his source for that is a 7th grade How to Do Your Science Fair project website. So that is not the only way to do an experiment.
I understand, and shout out to Q, love the guy. But I just wanted to know, because we're talking about the bending and warping.
Okay, here's the deal. If you don't like it,
I didn't realize that you were still talking.
Just to be sure, I promise we'll come right back to MCToon, but just to let let Ky finish.
A lady.
Thank you. I'm so sorry. No, I didn't realize. I think McToon just takes really slow breaths, and I'm just not really paying attention. But I understand what you're saying. I read your website. I looked at your sources regarding the scientific method, but that's why I wanted to bring up correlation versus causation, because right now we are talking about the bending and warping of space-time causing downward acceleration, correct? That's what we're talking about. We're talking about causation. So what I want to know is how you differentiated between correlation and causation, because the only way to do that is through manipulating the independent variable. Observation alone cannot differentiate between correlation and causation. And if you don't manipulate the variable, then at best you just have correlation.
Thoughts, Carissa or MCToon?
Melvin, do you want to take it? Because I think you were saying something. I don't want to.
No, you go ahead.
Your thunder.
You go ahead.
My response to that would be, regardless, I think the we obviously don't know everything about gravity. And I think that's fair to say. There are things that we do not fully understand. I don't know if you would totally agree with, that's my understanding of it. It gets into like general relativity and just a ton of stuff that you don't even get to until like PhD level plus, right? But generally speaking, you don't need to get into that level to see that gravity is consistent in the way that it proves a spherical Earth, improves the globe.
All right, real fast though, just because James was right, McToon and I do have some history, but I want to talk to McToon about this, right? Since we're talking about gravity, and I usually keep this in the chamber. Most people aren't ready for it. I know you're not, McToon, but you keep talking about gravity, invoking it. It proves the ball Earth, as she's saying. No, you look at the lights in the sky, you presuppose a distance, a certain mass, relative nature, then you presuppose a causal agent called space and time bending and warping and dilating, et cetera, et cetera. Actually, whenever we presuppose a theory of relativity, apply it to the universe, it's off by 95%. It's called dark matter and dark energy. Not only do you not know how to fully explain gravity, or have you ever proven it, it's not even mathematically viable yet. It's off by 95%. You should look into it. But McToon, here's my question for you. If everything is intrinsically electrostatic, and electrostatics is 10 to the 39th power stronger than gravity even claims to be, and all molecular and intermolecular electrostatic or attractive forces are electrostatic in nature, how is it that you isolated gravity and proved it to be the causal agent of something?
Well, if you think that electrostatics is somehow doing it, then I would love to see how it gets that 9.8 meters per second squared downward acceleration. Go right ahead.
Yeah, well, Coulomb's law was actually hijacked and changed into the little g, but I asked you a very specific question.
Coulomb came after Newton, actually.
Let me rephrase it for you because you don't seem to understand it, okay?
Wait. So you just claimed that
Coulomb...
You
will never answer it. I want the audience to know McToon 100% will not
Austin, this is important. You just claimed that Newton stole from Coulomb, even though Coulomb's law came after Newton's
I didn't
law.
say Newton stole anything, buddy, okay? What I said is that electrostatics explains the phenomena as well, right? But here's the question. It
doesn't explain it at all, because in a because here, lead is diamagnetic. It has a light lightly repels from electromagnetism. Lead would float if it were electrostatics.
Hey, is electrostatics and electromagnetism the same thing, McToon?
I don't know. You brought up Coulomb's law, but tell you what, you show me.
You
show me how it works.
McToon,
in a Faraday cage, things don't just float.
Are the things in the Faraday cage electrostatic? Yes or no?
Well, you were claiming everything is electrostatic, and electrostatics are cause for the 9.8 meters per second squared downward acceleration. So please present how that happens.
Okay, you had to straw man me. I want the audience to take note. 100%, I'll bet anything on it, McToon cannot answer this question, okay? So if electrostatics is 10 to the 39th power stronger than gravity even claims to be, and all molecular and intermolecular attractive forces are electrostatic nature, which I could cite Purdue University saying that it's just objective, okay? So all molecular and intermolecular attractive forces are electrostatic in nature. It's known to be 10 to the 39th power, that's 39 zeros, stronger than gravity even claims to be on the smallest scale. If you cannot isolate gravity by controlling the variable of electrostatics, how can you verify that the gravity is there, McToon?
Oh, it's easy to isolate electrostatics. You just have a common ground.
So when you ground something, is the thing that you grounded electrostatic, yes or no?
Both. If you have a common ground, both things are at the same electrical potential.
No, not electrical, electrostatic. Like I said, you're out of your league,
or electrostatic, whatever. So explain to me then. I'm waiting for you. You just keep asking the question. I studied electrical engineering. You studied nothing.
Which is why it's so sad.
So go right ahead and explain it. All you're doing is saying there's these forces, but you don't understand that they're all at zero potential differential.
Okay. Yeah.
How are they different?
You can never actually exclude the electrostatic potential of anything. Hence me just now citing Purdue University verbatim.
What's the link?
I'll get in a second.
Yeah.
All molecular and intermolecular attractive forces are electrostatic in nature. Do you agree or disagree with that statement?
That's fine, but if they're at the same potential, it doesn't matter.
Okay, so all molecular and intermolecular electrostatic or attractive forces are electrostatic in nature. And if we use a Van de Graaff generator manipulating electrostatics, it will change the directionality of things. They will go up and down. Lightning, electrostatic phenomena, bumblebee actually use an electrostatic resonance. Spiders and beetles do as well. So we have naturally occurring phenomena where electrostatics affects directionality. Everything is intrinsically electrostatic, glass, lead, you name it, anything. If you ground something, it's still electrostatic. It's intrinsically electrostatic. The earth is intrinsically electrostatic and way stronger than gravity claims to be. The official heliocentric explanation for this is that out on the bigger cosmological scale, when you get out to much bigger masses, it overrides it due to the scalar nature of gravity. So you should learn your own idea before you act like I'm dumb. And so that's just a side note, right? So you cannot, she already demolished you, bro. You didn't manipulate space and time, bend and warp it, and verify it's the causal agent. And electrostatics is still
no,
present.
you asked something, and you want me to answer it?
Go ahead.
I'm still you. All you need to do is understand that there's no differential. The electrostatic force happens if there is a electrostatic differential, but if there is no electrostatic differential, there's no force applied.
How do you control the differential of the Earth?
You were wondering about electrostatics, and I was explaining it to you, right? And then you changed it to something that wasn't about an electrostatic differential.
So the Earth have an electrostatic resonance?
A resonance?
A resonance field, yeah. Yes or no?
I don't even know what you mean by an electrostatic resonance field.
Okay, I'm sorry that you're
just making up crap.
Okay, so let me just all I'm saying is we can move on from this as a more technical aspect. It's actually not necessary, but all I'm saying is everything's intrinsically electrostatic. It's 10 to the 39th power strong, and gravity even claims to be. Okay, she explained to you that in 1915 it was superseded. Gravity is no longer considered an intrinsic property of matter. It's now considered an effect of the bending and warping of space and time. This has never been verified, scientifically manipulated. In fact, it's off by 95% when applied to the cosmological scale. It's called dark matter and dark energy. And then you can verify that causal agent. You certainly don't have some intellectual high ground where you can make fun of us with fifth grade science jokes. It's laughable. I read the theory of relativity. You don't need a PhD to do it either, Carissa. So here's the deal. You can't verify your causal agent claim, which is actually what your entire model is dependent upon, as well as the R value, which we've demonstrated that is falsifiable and in fact been falsified. So that's the crux of the whole issue. We'll never get answered. We'll just get ad homs. We'll just get little like shots about how you're so smart in fifth grade science. We'll do what, blah, 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 Pilton majority. But there you go. So until you can actually substantiate the cause of the downward acceleration, the fact we see the downward acceleration doesn't matter. We know that. But
it was empirically confirmed in 1915, and you just hand waved it away.
Carissa destroyed you on that, bro. Were you not here?
Carissa didn't destroy me on that.
Yeah, she did.
High five, Carissa.
Oh, I'm sorry. Yeah, Kai did. Carissa destroyed you earlier by disagreeing with you about the horizon. Sorry, I get mixed up.
Because obviously he thinks that there's a static horizon, right? Don't you? Right?
He thinks there's a necessary static horizon.
I love it.
The Earth is a
sphere. What's the Glover circle?
Wait. Though, guys, wait. What's the definition of air? Let's pause it.
Yeah, please. Tell me. Well, I already gave you the answer, so it would be quite fair.
Hey, Carissa, do gases have an inherent shape?
Atomically.
They haven't. Well, what's their shape?
It depends on their chemical makeup.
Do gases have an inherent shape?
Their molecular makeup. It depends on their molecular.
Hey, Richard Feynman would disagree with you.
No, I'm saying that each atom in the gas is going to have a molecular makeup, and that would generally, there might be some variation in the shape depending on how they interact with each other, but it honestly is, yeah. So it's not, of course, gas itself isn't going to be like, it's amorphous, right? But like on an atomic level, of course, there's going to be a shape to the atom.
Okay, so gases don't have an inherent shape. Okay, cool. I guess I got it. I was gonna say, so can you have gas pressure without a container?
Can you have what?
Gas pressure without a container.
Gas structure?
Pressure.
Pressure. Yes, you can.
Can you demonstrate it? Well, before we ask for your demonstration, we have a demonstration for you. Okay. So.
You hear that sound?
Did you hear it?
Yes.
Oh,
look at that.
Okay, so the pressure actually spontaneously sought equilibrium to the lower pressure around it once you remove the containment. Can you demonstrate gas pressure without a container?
So do you understand that the gas going into the air is floating up and it's being buoyant because it's lighter than the air around it? Of course, when you have a vacuum, it's not going to go up. It's not going to go up.
Yeah, maybe
Can you stop interrupting women, please? it's going to go up. It's not going to go up.
The joke reached its expiration.
Oh, I'm glad that you're able to determine that. So if you're able to go into like a vacuum, there are no other molecules or any other substances to help it float and disseminate into the air because there is no air. Therefore, obviously, it's not going to rise.
So to clarify, you just didn't answer the question when I said, can you have gas pressure without a container?
Yes, we have gas, an element of gas pressure here. I think it's probably determined by some effective gravity.
So the reason that we're asking this is because they tell us that the separation between our gas pressure here on Earth and the vacuum of space, which, as you brought up, is not like a vacuum cleaner. Everybody knows that.
It's not sucking.
Of course, yep, yes. They're saying that it's uncontained. It's uncontained.
Yes.
Now,
because the molecules still have.
So they're saying it's uncontained, but
there's still a mass.
The reason that we are puzzled, okay, because you want to talk about science. So we're curious because this is a good source, chemistry.elmhurst.edu. The definition of gas pressure is the pressure of a gas. The pressure of a gas is the force that the gas exerts on the walls of its container. So what's happening is the gas molecules, for example, like in your tire, we just filled up air in my tire today. That was a great example of gas pressure. It's the air inside, the molecules are colliding with one another and they're bouncing off the walls of the container, which is creating pressure. And the container is the antecedent to gas pressure, okay? So, but here's the problem, is they're just saying that the container that's keeping the air in from the vacuum is just air, okay? So that's the relevance of us asking, okay, the heliocentric model is claiming that you can have gas pressure without a container. So we would need to see this demonstrated on some small scale here on Earth. Because again, we can show you the Perrier can, my tire, a balloon. These are all gas pressure inside a container. So just show us one example, not using the thing in question though, which is the Earth's atmosphere. One small demonstration that confirms that you can have gas pressure without a container.
So number one, you're going to have to have such a huge gravitational force, right? Because right now what's happening is that the gases are being gravitationally pulled on a molecular level toward the Earth's core, right? So you can't reproduce the same situation unless you have such a broad scale gravitational pull, which is not something that we're going to ever be able to replicate. Unless I guess we want to go to like another planet and have like this huge experience. It's just not going to be practical, right? So generally speaking, the reason that it's still, I'm assuming that definition is assuming that it's within our atmosphere, right? And that there's going to be air around it.
If I can,
go ahead,
Carissa. There's atmospheric pressure, not gas pressure. So there's a distinction that you're missing there. So the definition you read doesn't apply to the atmospheric pressure.
The atmosphere
it applies to gas within a physical container. It's not speaking about the atmospheric gas.
To clarify, atmospheric pressure isn't gas pressure, right?
They are distinct, yes.
So the atmosphere isn't made up of gas pressure.
The atmospheric pressure and gas pressure are different things.
But is there gas pressure in the atmosphere?
There is pressure, but it's not due. Your definition doesn't apply to atmospheric pressure.
Okay,
it applies to specifically that definition that you read is specifically talking about within a physical container.
We have just a few more minutes, then we have to go to Q&A as we do have a number of questions and we are excited about them. So thank you very much. Folks, want to remind you a couple things before we do that as well. We'll give each of you, Carissa MCToon and Wittsit Ky, a chance to draw together some of the threads from this debate in just a moment. But I want to let you know, folks, Carissa and MCToon and Wittsit and Ky are all linked in the description, so you can check out their links if you'd like to hear more. Highly encourage you. What are you waiting for? I mean, the links are already there. So with that, Carissa MCToon, Wittsit, and Ky, any final concluding statements on tonight's debate?
Then go first.
Go ahead. You can start off.
Okay. Well, Austin, I sent that to you more than a year ago. I don't think you've looked at it. But and we didn't get to it. Maybe next time. mctoon.net/SE. Go ahead.
So I guess my closing would be that it's interesting. I think both Wittsit and his girlfriend, I'm sorry, I don't specifically remember your name because it's not.
It's just 2 letters.
Hi. Gotcha. I think that they're getting really entrapped by the semantics of things when many of the Earth can be obviously proven to be spherical without being like, oh, we need to understand gravity to a precise and dark matter and all this stuff. There are many ways to condense these perspectives and realize that the Earth is spherical. There are observational ways to realize that the Earth is spherical. There are many different ways to do so. And I think it's very interesting that they aren't even able to give a map or any indication of what they actually believe the world looks like. They seem very focused on like, oh, this is, common sense and stuff, but they aren't actually able to provide a map or anything, any model of their Earth. They say that it's not a positive claim, yet their shirts literally say the Earth is flat. They won't even say that they believe that. They're like, oh, well, we don't have to do that, right? Because they're worried they're spineless. So with that, go ahead.
Well, I really appreciate talking to the both of you. Carissa, I would love for you to join us. We have a Discord server called 24/7 Flat Earth Discord, where we educate new Globers on. Part of it is that you don't know your model. And when you learn the model, you find out that there's so many holes in it. So I invite you to come. We have Ladies Night at 5 p.m. Again, it's 24/7 Flat Earth Discord. McToon, I appreciate speaking with you as well. I would just ask that you, take a time to just think about the difference between correlation and causation. But overall, just to wrap it up with a nice bow, it's really good to question things. And I think everyone can agree with that it's very important to question things. And yeah.
Okay, yeah. So with the spherical access, by the way, McToon, I don't know why you keep bringing up our DMs, man. I guess I'll have to tell the audience now. You DM me 1,000 times, dude. So believe it or not, no, I don't read all your DMs, bro. I think it's super weird. So there you go. There's your interest in that.
I did it in a debate on this platform. I did it in a debate. I sent it to you during the debate last time you were
Not
here.
my boyfriend's DMs.
Yeah, McToon, I think you actually interrupted my closing. It's cool, but I get it. You get triggered, but I haven't checked my DMs during the debate, and you've sent me hundreds of messages. It's all good. Spherical excess, you actually look over a vast distance. You say that there's no refraction, but then right after that, you can rewind for the audience. He literally said, well, there is some. You got to account for it, and whoop-de-whoop. Yeah, of course, there's refraction, there's a fluctuation. You take an apparent location, presuppose a radius value, presuppose the Earth's a sphere, and then you take the fluctuation of the differential in the apparent location, and then you say, look, here, it's more than 180 degrees, and we don't need refraction. It's not really here, but it's kind of here. Wow, dude, that was really difficult. Please send me some more through the DMs. So, and then she said, oh, if the moon's a sphere, we don't presuppose the moon's a sphere. We've seen the same side of it forever. So no, that doesn't prove the Earth's. Well, I can go through your entire info right now. It's not true. It's all dumb. It's all presuppositions. What we'll always get, and oftentimes, is how many times will Austin say specificity or presuppositions? I'm sorry that Globers make me say presuppositions to every one of their postulations, but that's what it is. So here's a quick recap of the situation. We pointed out that the horizon that we see is nothing more than an apparent location. It constantly fluctuates based on atmospheric conditions. It's called a horizon because it's horizontal. That's what we've all observed. Anyway, so then we looked at long hallways and railroads. They always converge optically, right? That's what we know. That's what we can replicate. That's what we can demonstrate. That's what we observe. You say, well, that's what we observe, but there's something else going on that we just don't ever see because NASA went to the moon in 1969, right? Like that's what you're saying. And that there's an apparent location you can't tell. You can presuppose that it's there, presuppose a radius value, fluctuate it with the category error, then come up with some mathematical equation that doesn't even work, and then that makes the Earth a ball. Cool story, bro. We've seen mountains 273 miles away, 255 miles away. We falsify the radius value. It is impossible that we live on the radius value that they say that we do. It's impossible that we live on the raceway that we say that we do. We falsify the fact you don't have the causal relation for gravity. So there you go. We talked about the basics. Just look into it. I do this for the third-party viewer as the she. Just open your mind. I know it sounds crazy. I thought it was crazy. Don't be a zealot and try to defend the government via Stockholm Syndrome. It's okay. Don't make this weird, bro. They lied. I just encourage you to look into it, and then you will find out that, in fact, all the empirical evidence is on one side. Thank you.
Move into the Q&A. So do want to say thank you to all of our guests. As I had mentioned, our guests are linked in the description. Also have to let you know a very special link is pinned to the top of the live chat. Folks, we know a lot of people enjoy debating these topics, and maybe you have a new YouTube channel, a podcast, whatever it is that you want to get exposure. Well, that's how Modern Day Debate works, is it's all built on exposure. So for example, all of our guests that are here right now are linked in the description. We encourage you to check out their links. And if you want to come on and debate either flat earth versus globe earth or creation versus evolution, I have pinned a Google Doc or spreadsheet at the top of the chat. So if you'd like to come on and debate one of these topics, or maybe you don't even have a channel that you're trying to get exposure, you just enjoy debating because you're sick like us, well, go ahead and enter your info into that spreadsheet that is pinned at the top of the chat right now. And with that, thanks so much for your patience. We're jumping into the questions. Alex Stein, old friend, says, Austin and Ky makes my heart swoon. Love flat earth for the win.
Yeah, shout out Alex Stein. What a legend. And go sub to Conspiracy Castle, or you could be super lame. Much love.
Let's see. Melvin, MCToon, you might enjoy a debate with Alex. I don't know. I feel like you guys would have a good chemistry. But made by Ben Jim Bob says, MCToon, what are the physical properties of space-time?
The physical properties of space-time is 4 dimensions. That's what it is.
You got it. And Chris Gaiman, thanks for your question, says, Flats, how much does air weigh? Do you believe matter nearby the Earth is attracted to the Earth?
Wait, sorry.
Flats.
Is that for us or for, sorry?
Flats. It
for
was,
the flats.
the
The
question.
flatties. Ready?
What's the question?
They say, how much does air weigh? And do you believe matter nearby the Earth is attracted to the Earth?
Okay, matter is no longer has an intrinsic property of gravity. We've already explained that gravity is no longer an intrinsic property of matter. But anyway, like what is air? Air is certain types of gases. What is the weight? What is weight? It's acceleration relative to its location and to its density disequilibrium or relationship. Very simple. Gas always fills the available space. A gradient is a non sequitur. So there you go. Like, yeah, there's a gradient, but there's still a pressure. That's delta X change in X. We're talking about the antecedent requirement for X, which is that there is a container. So that's called a non sequitur.
You got it, and thank you very much for this question coming in from C. Mitch Play. Says, Flat Earthers, can you determine where a heavenly body will be based on a time and location on Earth? Because Globe can without using historical data.
Hilarious enough, actually, NASA still utilizes the Sero cycle, and yeah, it's in a repetitive cycle. Hence why you know why it's there. You're just explaining to explain the cause. It's called post-diction, not prediction. So you looked at it.
You should look up ELP 2000. You don't understand it.
Oh, okay. First of all,
welcome.
Juicy, this one coming in from Sofa King Sleepy says, KY, they are going to stick with that. Obviously, when stuck, they will need some more teaching from an astroglitticist.
Great. I just tell if they would like to talk to me personally, just come to 24/7 Flat Earth Discord. If you're smarter than me, let's see what you got.
You got it, and thanks very much for this question coming in from GPS. Says, both sides, how does GPS work?
You go first.
The satellites send their location and the time from the specific location that they're at. The receivers get the time and the location from multiple satellites and trilaterate the distance from the different satellites that they're at. And having that, they can get their exact position. It's an open standard. Anybody can create their own antenna and capture that data themselves and see if it works and see if that location is where it appears to be from.
Interesting. Yeah. So just for some Globers that don't know, right? Some people say that GPS is global positioning satellites. I think most people know that, and that's global positioning system. The RAN system long predates it being called something to do with the globe. 99% of all transmission are using towers and underground sea cables and wires, right? So we don't actually even utilize the idea of space, certainly not free falling in a vacuum of space. Even if there was something in the sky, which I can actually give you plenty of scientific evidence as to how that was possible on a flat Earth. It doesn't verify the Earth's a magic spinning cartoon ball that defies physics. So almost all the transmissions are using that. The Loran system came long before you called it GPS, and that's the exact use case of GPS. So it's certainly not exclusive to a globe.
You got it. And thank you very much for this question coming in from Sarcastic Barman says, Flat Earthers, what's the distance around Antarctica? Please bear in mind before you answer, there is a race around it.
Yeah, so the supposed sailboat race that goes around Antarctica actually goes down and pops back up. They published publicly their actual route. It goes down and pops back up. So that just shows how little people research. We couldn't actually verify the distance around Antarctica because it's illegal to do that via the Antarctic Treaty signed in 1959. Longest lasting peace treaty, not even up to review till 2042.
What page has that you can't go there? Can you cite that?
Yeah. It tells you that it all adheres to beyond the 60th south latitude, and you cannot privately or freely explore it without. Can
you show the exact,
sure
which article of it says you can't go there?
Article 6.
You just make that up.
We done?
John Rapp says.
So we can.
John Rapp says, GPS. Evil NASA rubs their GPS satelloons vigorously, makes them stick to the dome. Flurfs. Hashtag rub your satelloon.
Straw man fallacy.
Gotcha. Yeah. And Sunflower says, MCToon, when we set up a vacuum chamber and observe things in it, there is no medium modifying or obscuring it. Correct?
That's right.
You got it. Andrew Rouse says, statement, you two are the perfect couple. I think that they're talking with you, Wittsit. Gotcha. Next up, Roger Polak says, MCToon says MCToon, please make a soundboard for greatest hits, PTS.
PTS.
I think they mean make a soundboard of Austin.
Oh, I already did.
I know you're obsessed with me, bro. It's getting weird. Get out my DMs and record my voice, bro.
Kang024, thanks for your message. As a reminder, want to remind you all, folks, in the live chat, attack the arguments instead of the person. Super important, folks. We really do want to encourage you to rise to that standard. 99% of you do a great job. And for those of you who are not yet there, believe me, you're going to get there. And Joshua Alex says, for both, take 2 cesium clocks, one at street level, one at the top level of a building. The tower clock will soon be behind. How do you explain this?
Right, yeah. So what they do is they say that space and time was proven by the oscillation rate of a cesium atom and its degradation. Of course, they don't account for the vibrational pattern or where they are within the vortexual, movement of the electromagnetic field. We'll say for intended purposes, not to make people spiral. So yeah, there's numerous different variables they don't control for, and then they just look at the degradation rate of a cesium atom, the oscillation rate, and then they presuppose the causal agent being space and time, which is called a reification fallacy.
You got it. And Peace Pie says, can Fletcher explain the moon's shadow in all phases? Who is Fletcher?
Flat Earther?
Maybe they mean, I don't know. If Fletcher, yeah, it must be you, Austin. Go ahead.
Yeah, I don't know. I don't make unfounded claims. Actually, you can actually create, people spiral over this. I just don't care what people think. So you can actually replicate a naturally occurring hologram with the polarization of the electromagnetic field that replicates the color changes, the appearance of shadows, and the phases of the moon. We've only seen one face of the moon for all recorded history. You claim it's entirely locked. It's a coincidence. So cool story. Falsification is independent of replacement. We have the Stellanian eclipse, the eclipse where the sun and moon are both above the horizon during the lunar eclipse.
We're never going to get done if he just waffles like this.
Where the Earth is blocking the sun, supposedly casting a shadow onto the moon and going the wrong way. So we falsified your claim, and falsification is independent of replacement.
Gotcha. And then Andrew Rouse says, Austin, in 15 years, when you look back at all of these debates, how are you going to deal with all the cringe? I don't know if they mean cringe from you or from the opponents. I'm baffled.
Yeah, I don't know. It's going to be really hard to rewatch McToon implode like this. But I'll try and make it through it.
This is the next step. The Science of Science says, MCToon, a convex surface does not mean the Earth is a globe.
Correct.
Next up, RT96 says, our view of a pencil in a glass of water is affected by refraction. Wittsit says, quote, there is no pencil, bro. That's my best impression. Sorry.
That's a good one.
Okay, at least you do the bro in there. It's not too bad. Nah, dude, no one said there was no pencil. That's not analogous. That's a much more dense medium called water. So cool story. And in fact, you require the isolation of a physical location called the geometric horizon. So cool story, bro.
Kango24 says, Wittsit, Earth's curve can be seen. Its location is just refracted. Just like looking at a pencil in the glass of water, is the pencil not physical?
Earth's curvature can be seen. You just don't actually see it because it's completely refracted, and then we see something else. That's what he said.
McToon already elaborated on that.
We can physically manipulate the pencil, not the curvature of the Earth. Next
up, Science of Science says, Carissa also thinks a convex surface means a globe. That's a pretty big leap in logic to think convex equals globe.
I don't think I ever said that.
You got it?
No, because I don't necessarily believe that. So.
Deal. Don Kedick says, I love modern day debate. Gets me through my workday. Thanks for your encouragement, Don. It means a lot. And Fat Man says, KY, you can't compare, I think they mean Kai, says you can't compare a laser sliding on a table to the sun setting. The sun is not suiting on Earth sliding away from us.
That's literally what
they meant. Sliding.
That's literally what it's doing.
I think they meant
and you
sitting.
can even see this with the videos of the shrinking sun. That only a shrinking sun can only happen if because of angular resolution. That's it.
Gotcha on this one coming in from Digital Demonic Dabro says the damn Santa silly man argument is a red herring by Wittsit. This man is not even addressing the argument in this argument. He strawmanned the whole conversation.
No, it wasn't a red herring. And by the way, I said Superman, not Santa, because she said there's an actual tree that we know is there. We don't know the curvature's there. That's why her thing is laughably rudimentary and inadmissible when it comes to empirical evidence. And then she said we control the variables by using a light, which you don't control the atmospheric refraction. So I was being very specific as to say, well, I've never seen Superman. That's why I still know that he is there. That's what she's saying. We've never seen the curvature, but we know it's there. So try again.
No, I just was specifically addressing your claim that just because we have to account for something doesn't mean that we don't actually see it.
Specifically, just because we've never seen it doesn't mean it's
no,
not.
No, that's not what I'm talking about. I'm talking about this.
Cut you out of the debate saying it 3 times. So
no, I'm talking about it specifically that you can't, just because you don't see something directly doesn't mean that it's not visible by controlling elements around you. That's my only point. It's not a one-to-one comparison on all values. But go ahead, James. I'm sorry.
No worries. The Batman says, Austin triggered MCToon good and hard, LOL globies. Very good. All right. Next up, John, he told me how to pronounce it. Sudlick says, I love Wittsit, but Kai is better looking. Sorry, dude.
No offense taken, bro.
This one coming in from Displaced Gamer says, if gravity does not exist, why are objects in space spherical?
Wait, sorry.
What?
What happened?
I think this is, so that's for you. So they say, if gravity does not exist, why are objects in space? Why do they all tend toward being spherical in shape?
Wave.
Yeah, see, actually, you can't even substantiate sphericity or terra firma. I actually document them all the time. They're pulsating, quote-unquote, orbs of light for intensive purposes. And even if I look up at a cylinder and say, there's a light bulb, that means the ground's a light bulb. That's not very adequate information now, is it? Plus, you presuppose the mechanism that causes it all to happen. Presuppose the medium being a vacuum, which is literally antithetical to the natural law called the second law of thermodynamics. It looks like a more fluid-like medium, but that's for people that are open-minded.
Gotcha. And this one coming in from Rai says, make sure you wear your NASA shirt when you get your 5th booster shot. I think that's for you, Carissa. Are you going to wear your NASA shirt?
Yo.
I'm being deafened right now.
That's hilarious, bro.
Was that for me? Of course I'm going to get booster shots.
Oh, no, I was just in general.
Of course.
Yeah.
Next up.
Yeah,
okay.
I'm for science.
Next
yeah,
up, Raza43 MCToon. You're not going to get a booster shot? Jeez, man. Okay. Raza43 says, if anyone lets go of a helium balloon atop Mount Everest, it will fall. Why is that flat earthers? How do grown-ups not know this?
What happens when you pop the helium balloon?
Deflect.
Oh, that was so hard. Oh my gosh. Lasers are so dumb.
Let's see. Thy Messenger says, I never have seen McToon so triggered. Ha ha, he lost. It's just so trollish. They say it's so blatantly. They say, ha ha, he lost today. He needs more anti-truth media training. Hashtag Black Swan photo. MCToon, any thoughts?
I've definitely been more animated in some. I think people might be able to identify when even. But this was fun.
This one coming in
and
from...
it wasn't you, Austin.
I wouldn't laugh too much, Austin. We got a juicy one. Xanos Carthage says, hey, have you seen the footage of Wittsit getting beat up by an MMA fighter? I think he tapped out 6 times. Is this true, Wittsit?
No,
that was
I got hands, bro. Leave with the left.
Was it against MCToon?
No. I got hands, bro. Leave with the left, James.
Next up.
Wait, hold on. Was that you or are you talking about, did somebody mistake you for right the hand?
I didn't get tapped out by anyone. That's all I can say about it.
All right.
Wittsit doesn't get tapped out by anybody, folks. And then Snake was right. Says if density creates direction. Thank you. Snake was right. Thank you for your question. Says if density creates direction, why do things not fall up toward the less dense air? Clearly, the direction of most mass is what determines direction.
That just made me lose brain cells, but it's the object's density relative to the atmosphere or the surrounding medium. So if something above it is less dense, that's non sequitur. It's more dense than the surrounding air where it's currently residing within that medium.
Like an ice cube, you drop it in room air, it falls to the ground. You drop it in your cocktail, it rises to the top.
You got it, and thank you very much for this question coming in from, you guessed it, Robert Summers says, Flat Earth wants to claim science is on their side. Can you tell me one model in the Flat Earth that makes testable and accurate predictions?
Well, models aren't science, so that's convenient, and we're actually not allowed to privately travel past the
models absolutely are a necessity in science.
Look, man, all the super chats are for us, okay? Just in case you weren't paying attention, but so you're not allowed to privately explore past the 60th south latitude. So to make claims outside
but you didn't. But you didn't substantiate that claim yet, Austin.
No, you're even triggered in Q&A, McToon. You need a jail, bro.
But you didn't substantiate that claim. You're just lying.
Okay.
Maybe if you just stopped lying, we wouldn't have to
Asar,
you.
Asar,
Are you done?
You always lie.
Yeah, all I know is the super chats are for us. That's all I know. So you can't go past the 60th south latitude.
That's a lie. Why are you lying again, Austin?
Next up, Asar.
Why are you a fake Christian, Austin?
Asar M.
Why are you a fake Christian, Austin?
Asar M. Ka says, if gravity doesn't exist, have them explain the cause.
Oh, yeah. Everything's intrinsically electrostatic. To be more specific and technical, incoherent dielectric acceleration. You can use a Van de Graaff generator, affects directionality. You can slow me down to 0.5 since it's just word salad, even though it's all coherent, very hyper-specific. All molecular and intermolecular attractive forces are electrostatic in nature, and since it's 10 to the 39th power stronger than gravity and claims to be, you certainly can't claim gravity, so everything's intrinsically electrostatic. Density disequilibrium is the relative characteristic that is most prominent. Write it down.
This one coming in from, do appreciate your question, Scotty Osborne says, MCToon, do you abuse human growth hormones to get those unusually large muscles, which is actually cannibalism? Are you on the roids, MCToon?
Not. It's just it happens naturally.
Pseudonym, thanks to your super sticker. And Made by Jim Bob says, MCToon, what are the necessary constituents of a scientific experiment?
Scientific experiments are not dogma. So the necessary constituents that you're talking about are, again, from QE, where he tries to make science into a dogma. So no, it is not the IVDV dogma that he talks about.
Independent, dependent, and control variables, the answer.
Yeah, but control variables, which you never do, but those are just dogma. That is not actually the necessary constituents of a scientific experiment. That's too rigid.
You got it. This one coming in from Made by Jim Bob says, MCToon, how can you justify the bending of space-time if it has no properties and requires time and space to be constant to measure its bend?
It has been empirically confirmed. So I'll stick with empirical measurements.
This one coming in from Nephilim Free says, the flat earthers are interrupting too much.
Wow, literally we got interrupted the entire time. Maybe rewind it.
Nephilim Free might be up for a debate with you, Austin, on Flat Earth. I don't know. I'm just saying. Dr. Bass, Ackwards says, Carissa, draw a circle on the ground, then draw a circle around that, then another circle around those circles. If you continue like this, will the circles keep getting bigger? Can the circles ever shrink?
It would literally just be your latitude lines, right? So yeah, it would keep on getting bigger and then they would start getting smaller again.
You got it, Ann. Thank you very much. Andrew Rouse says, could everyone please just say what higher education degrees everyone has, starting with you, Kai, and Austin?
I got a PhD from Critical Thought University, and she got from Free Independent Thinking, not Brainwashed. Actually, you can actually answer.
I have a bachelor's in science, so suck it.
What science?
Irrelevant. Bachelor's in science. You can look it up.
Okay.
That's the name of a degree.
Okay, yeah, but typically you can get a BS.
What about you, Carissa? Why don't you answer the question?
Sure, I'd be happy to. In December, I'm getting a Bachelor of Science in Mathematics.
Right.
Okay,
Perfect.
so you're almost where she is. Why are you knocking her down?
I know I'm not. I'm just asking for further clarification. I think it's cool, and I'm curious what specific degree she got. Why are you
got a
being
PhD.
so
You're
bad
not
faith?
impressed? I have a PhD in critical thought.
All right, go ahead, Melvin.
Go ahead, Melvin.
I study electrical engineering and computer science.
And you still don't know what electrostatics is, James. We got another question because we're trying to go to the strip.
Next up, Andrew Rouse. Richard Ashton says, shamefully embarrassing show from the flat side. Unbelievable.
That seems like a coping mechanism for the self-projection of how they got intellectually eviscerated. I'm just being honest. The earth is flat. Don't make this weird, bro. Check out the merch store. I got you.
This one from Kit says, Wittsit, that gap from your rotting... this is weird. They say, let's see. Is it big enough to whistle? Gosh, what is this about?
It's a dig. You probably should skip that.
No, just read
Next
it.
one. The Science of Science says, I have to give it to MCToon. He makes me laugh so much. He is my favorite globe myth enthusiast. Oh, that's nice.
Thanks.
Next up, Snake was right, says, higher elevation, lower pressure, no container.
Yeah, that's called a non sequitur. Delta X, change in X. We're talking about the antecedent. Let me slow down. The requirement for the pressure, which is X, the change in pressure is an additional piece of information. So we're trying to figure out how we have the pressure. Once you invoke the differential or change in pressure, that's a non sequitur.
This one from Nephilim 3.
Without pressure, gas pressure.
Neff says, if the earth were flat, there would be only one time zone for the world since the sun would rise in the same... Hold on.
Yeah,
rise in the same hour for the entire earth. In all caps.
That's wrong, actually.
Wow, that is incredibly dumb. But yeah, the sun's more local. It has a radius of light for intended purposes. It's called attenuation, absorption of the medium. Light does not travel forever. It's much more local. You can replicate it certainly using a dome.
Experiments in prebiotic chemistry says, why is the air on the top of Mount Everest thinner than the air at sea level?
There are numerous different aspects. For one, we don't actually know the characteristics of the containment itself, the medium differential all the way at the top, and gases are being constantly introduced and produced at the surface level. Now that I've addressed your non sequitur, can you address the first one that you skipped past, which is how do you have pressure in the first place?
Robert Summers says, Wittsit, if I drop a bowling ball from a building, do you agree or disagree it will fall at 9.82 meters per second?
I disagree because it's completely fluctuates. It's never consistently 9.8 meters per second squared, and it's dependent upon an incredible amount of variables, including the location on the Earth.
Made by Jim Bob says, MCToon, so gas pressure equals container, but atmospheric pressure equals pressure without container, but it's still gas? And...
Without... Okay,
go ahead.
Sorry.
No, it's a good time to go.
Without a physical container, absolutely, because there's just a pressure differential from the ground level to any particular elevation you want to pick. You can see that, you can measure that in flat earthers balloon launches with barometers on them. You can see that there's a pressure differential. That's our claim. There's a pressure differential. That's it.
This one, made by Jim Bob, also says Moderna or Pfizer.
Neither.
I'm organic, homie.
Pfizer.
Oh yeah, the one that's not
MCToon. You have no MCToon. Have you not gotten it?
I'm ambivalent.
Next
you
up,
guys can see my merch.
You and Austin are strange bedfellows on this. Don Keddick says, if stars emit light from nuclear fusion, then why doesn't their gas just dissipate into space? Where is their container?
Because they're more dense than space and gravity, they have mass. Therefore, gravity attracts them to the Earth.
You got it. And Elijah Freeman says, Andrew, TY used a plane for his atmospheric refraction computations. In another section, he superimposes this onto a curving surface with a radius of 3959 meters. The black swan is 1,000% off from 1.2.
That's for the Globers, in case you didn't follow it. It was a smarter
that's
guy.
because it didn't include refraction analysis.
We just talked about that in the question.
Yeah, that you demand. Yeah.
Next up, Ryan says, getting a degree immediately raises your IQ by 20. Thanks for that, Ryan. From Duckery says, Austin, how is the Tropic of Capricorn measured smaller in circumference than the equator? Ships, flights, and land masses prove this fact. Flat Earth debunked.
Oh, wow, it's crazy that 9% of all people that inhabit the Earth are actually in the northern quote-unquote hemisphere, which is stupid because there is no sphere, and that's completely a lie. That's not true at all. How do you physically measure it? Because it seems like we've been trying to physically measure the convexity of terra firma for years, and we can't find it, including the Globers. So, cool story, bro.
Thy Messenger says, MCToon on a, quote, micro scale, show us a spinning ball containing water on its surface while it spins. If it's a globe, it can be replicated. Earth is flat.
The fallacy is if it's a globe, it can be replicated because there is the gravitational force that we can't get out of. So here's the deal. On a micro scale, flat earthers can't demonstrate their flat Earth in some sort of a terrarium either in any orientation, because if gravity doesn't exist, then can't they hold it sideways or upside down?
Hey, look, the water fountain is level. I just demonstrated it.
Take the lid off. Take the lid off. Hold it upside down.
Why would I do that? That's non sequitur.
Oh, because gravity affects these experiments. You can't do it without the effect of gravity.
So if we
changing the experiment.
Gravity, if we presuppose gravity, you can't prove.
You cannot control that particular variable.
If I pour water in a pool, what happens?
Turn that pool sideways.
Why? That's not what the Earth is.
Ball. Why doesn't the ball?
Are we serious?
This
Because
isn't.
gravity
This
has
is,
to do with
this
mass.
is absolutely mental handicap. You guys are making fools of yourselves publicly.
Stop self-projecting.
We
This
are
one coming
right.
in. Scotty Osborne says, Wittsit, congratulations. Make sure that Ky is not an Order of the Eastern Star or daughter of the American Revolution. What does that mean?
I don't know, man, but I'm not going to take relationship advice from anonymity on the internet. But thank you, though.
Gotcha. And Made by Jim Bob says, MCToon says, or they say MCToon, so the physical properties of space-time is, quote unquote, 4 dimensions. What are the physical properties of, quote, 4 dimensions, unquote?
It's over.
Yeah. I think, he could maybe get educated. I'm not gonna.
This is epic.
No, why aren't you just doing a whole,
Or she acts like
class
she's smart.
in 2 seconds? Why can't you just do a whole class in 2 seconds, right?
Yeah, explain relativity in a response to a super chat.
Next up, C-Image
To
Play
people
says,
that don't understand 5th grade science.
C-Image Play says, all right, we're going on to the next one. C-Image Play says, I built a GPS receiver from scratch, software and hardware. Wittsit, you're wrong.
Does it use Cartesian coordinate systems? Oh, yeah, of course it does. Next.
You got it. And
What?
Robert Summers says, does.
She doesn't get it, and she's
What?
laughing. Anyway,
It's not Cartesian coordinate system.
they don't use Cartesian coordinate points?
No,
Really? What do they use, McToon?
it's spherical coordinate system. And if it's
Really?
flat, it's a polar coordinate system.
Oh, but they use
It's not Cartesian.
I'm sorry. They use Cartesian coordinate systems, and the Lorentz system, which is identical to GPS, predates the GPS, right, McToon? Yeah. Okay.
Do you understand?
We're trying to go, McToon. Next.
You can map between coordinate systems. Do you not know that?
Yeah. Did you know that
okay,
Lorentz
good.
system
Excellent.
predates the GPS?
Excellent.
Never
This one
gonna
coming in
match.
from Robert Summers says, does DirecTV know the Earth is flat?
Yeah, well, if you actually look up DirecTV, which is typically contracted to American Tower in the United States, they admit that all their it's all used with towers. So this is awkward.
No, they don't.
Oh, so American Towers aren't their main contractor?
They don't admit it's all from towers.
What are they? So how much? What
Stop
percentage
lying.
of it? What percentage
Why-
of a satellite?
why
What
do you
percentage of
have
a
to lie?
satellite?
If you point a satellite dish at the sky, it's from a satellite.
Can you maybe have something at a higher elevation?
You'd see it, Austin. You'd see it.
Can you? What? You can't
Mike.
see forever, McToon. Next.
Are they building a tower?
I'm
They're building
sorry.
a tower that you can see.
You think we landed on the moon?
Deflect when you lose.
I'm
Got
just
it.
saying, it's like I just want
Of course we landed on the moon.
Understand how lost you are.
Oh wow.
Of course we landed on the moon.
Of course we did. That's patriotism. Next.
This one coming in from,
What a
appreciate your
douche.
question, Mike Menzies
Absolute
says,
douche.
You thought it was funny.
the stars are angels, the sky is a dome, flat earth for the win. Austin, you the man.
Yeah, I can't even disagree, yo. But I know that it does appear that if you look at star in a jar sonoluminescence, and you integrate cymatics, yeah, you can actually integrate different frequencies within a fluid-like medium. It creates the exact same phenomena that we call stars. So I don't know who needs science when you can believe the government.
This one coming in from Truth Nerd says, on the AE map, the Vendée Globe record holder would have had to average 30 knots in a one-man sailboat. No wonder Wittsit refuses to commit to a map.
Oh, wow. So if we presuppose the Earth's a sphere and then the route that they say is true, and then we don't acknowledge the fact they actually went down and popped back up from the very northern part of Antarctica, Austin's stupid. And then we can presuppose a flat Earth strawman model, and that makes that a certain miles per hour they would have to go, and therefore Earth's a bomb.
King at V says, ask Wittsit what a radar horizon is. And it don't care about refraction. The distance to horizon never changes throughout the day or days if the high don't change.
I'm so glad that you guys brought this up. Marconi, first one to send radar, right? So 2,200 miles, his attractor said that it wouldn't work because it would hit the curvature of the Earth at 200 miles. Guess what he did? He hit his target at 2,200 miles, first time utilizing this line of sight. We now actually send radio waves over 10,000 miles, never ever accounting the convexity of physical obstruction of the Earth curvature. No, it just goes up and it bends back down perfectly because the Earth's a magic bomb. And just
only for certain frequencies because it bounces off the ionosphere. Use different frequencies and it doesn't bounce. You can't go that far.
Oh, really? So can we go 10,000 miles with radio waves?
It depends on the frequency.
This one coming in from, do appreciate your question. From Duckery says, James, please yell loudly, I love midgets. And C-Mitch Play says, MCToon, can you please explain to Kai why the sun doesn't shrink as we see it?
Why this? All right. So the sun does not shrink. The size of the sun is always consistent. When you show videos of the sun apparently changing size, you're just seeing the size of the glare change. When you put a solar filter on there, the size of the sun is always the same.
Did you know your model actually claims?
Hold on, I'm not done. Why is that? The reason why is because it is extremely far away. Now it does change a very, very small amount. It's exceedingly small, and it's difficult to measure. Certainly nothing that you can without high precision instruments.
Oh, so it does change.
So it
Okay,
does change?
thank you for saying she was right.
Okay.
But it doesn't change nearly enough as if the Earth were flat.
So it's
Strong man.
Coming in from, I'm going to give MCToon the last word on that one, as this is one of the few questions for him.
Yep. Oh, on that one? No, I'm done. I have a video on my channel.
Like, explain this to the other person. You don't just get to
No,
say
you're not MCToon. Okay.
All right, well,
I have a
they've done
video-
that 12 times, but anyway.
I have a video on my channel that's a montage of different people that have done solar filters, including one from a flat earther, Felipe. Poor guy. I told him he should get a solar filter and do it, and he did it. And it was the same size, and then he blocked me.
You got it, and this one coming in from Bryantology69 says, Wittsit, do you not presuppose the laws of logic?
Presuppose the laws of logic? Okay, maybe you should look up the hyperlogical route of deduction, right? Okay, and so whenever it excludes any presuppositions, and you tell me what you're left with when we never determine axial rotation with any naturally occurring observable phenomenon or experiment ever, and then all empirical measurements of the Earth is flat, and then we see the sky reset for all recorded history. You presuppose adding to the hyperlogical route of deduction, which is called Occam's razor.
This one coming in from Isaiah 40:22 says, Carissa, given the Bible is 100% a motionless flat earth book, are you willing to bet your soul that the earth is round?
Yes.
Next up, made by Jim Bob says, MCToon, are models valid substitutes for experiment?
No, a model is a necessary part of an experiment because you can't create your hypothesis without a model.
Next up, Fat Man
Hypothesis
says,
is the model.
Wittsit doesn't realize that the loser usually gets the most questions at the end of the debate.
What I don't realize is how it is that people come claiming that flat earthers are stupid and constantly watch me talk and watch us debate it. It's so ridiculous. And the reason we get all the questions is because they think that if they team up and spam Austin with questions, eventually the earth will become a ball. And they don't want to ask the Globers a question because all they have to do is regurgitate what Google says.
Next up, Robert Summers says, what did you manipulate when you confirmed the whole world is inherently electrostatic? Or did you just accept that as a facet because it fits for you?
All experimental data in the history of mankind shows that all molecular and intermolecular attractive forces are electrostatic in nature.
Didn't answer the question.
Yeah, I did. If the Earth is molecular, how is it that it's not electrostatic if everything is?
What variable did you manipulate?
What variable do you manipulate? You can't manipulate the electrostatic.
Oh, you didn't. Okay.
It's intrinsic in the matter. That's what my question is. How can you manipulate and control the variable for electrostatics if that's required to isolate a much weaker, quote unquote, force gravity? You should rewatch the debate and take notes.
Next up, Brainy Beaver says, quoting Wittsit, saying, Wittsit says, my friend supered, I win.
Oh, wow. Ad hom. Earth's a ball. The government would never lie. Take your booster.
Next up, Thank the Most High God says, does MCToon have video of globe spinning in space?
I do. There's a Turkish flat earther that challenged, put a $250,000 challenge out there. So I got, I think, 3 different videos of the Earth spinning in space.
Next up, Chad Martin says, have we gone over the parallax effect and the differences in the observance of stellar constellations from each pole?
Is that a question for us?
We didn't cover that. I think that's for us. Carissa, maybe you yeah.
Yeah, so it's just a fact that if you're in the northern hemisphere, you see Polaris all throughout the seasons, which is something like they can also not account for the season changes along with daylight. And so that alongside the stars, and you see the rotation of the night sky, but the Polaris typically always stays the same because that's where the axis is through like the North Pole. So that's just like one of the many things that you can just view with your naked eye.
You got it. This one coming in from, what have you got, Kai?
I was just going to ask Carissa a quick question. Carissa, when the northern hemisphere is closest to the sun, what season is it?
When the northern, it's summer.
Incorrect. Thank you.
What are you talking about?
Yeah. Go learn your model. Thank you.
No, it's tilting toward. Yeah, no,
when the northern hemisphere is closest to the sun, it is winter.
No,
nope. Just Google it.
Just look it up, Carissa. Next.
It's not true.
Next up, Aaron Reese says, can the flat earthers actually make an argument instead of spewing techno babble? Trolling and laughing to deflect from their ignorance is a con man's tactic.
Yeah, if you run your hand over a pregnant woman or a pregnant woman's stomach, you can't see it once it gets to the bottom because it physically obstructed. Earth would have to do that with the sphere, but it doesn't. We've measured it all over the place.
Next up, Fum Duckery says, Austin, so I told you how it was measured, and you wave it away. Answer the question and stop dodging.
Believe it or not, I don't remember random gamma males on the internet super chatting me and what it was you asked me before, but you've never physically measured the Earth being a ball. I must presuppose the radius value, then look at a fluctuation of an apparent location and actually somehow tell me that it's an actual location, even though it's not an actual location, but we can minimize it not being an actual location. I promise it's real because the government told me to.
This one coming in from Thank the Most High God says, MCToon, what are people on the other side of the globe seeing if I can observe the sun and moon during the daytime?
Directly opposite side of the Earth, they would not see the sun and moon.
You got it. Lael says, we know that the sun's light illuminates all 3,000 miles of the USA. Austin, what is the limitation of the distance of light ability to illuminate?
What's the distance, or what's the like the confinement of distance illumination? Like,
yeah, how far can you see the sun?
What's the confinement of the illumination distance, MCToon? Yeah, I just said that. So why would it be that I need to presuppose the characteristics and the distance and the radius of light to somehow scoop past the fact we falsified your assumption it's 93 million miles away? That seems kind of awkward. This is getting weird. Like, there's a radius of light. You said that there would be light over the entire Earth at the same time if the Earth was flat. And that is like third grade level dumb. So
Lael says we know that the sun's light illuminates all 3,000 miles of the U.S. Oh, I just read that. Sorry. David Villar says you cannot go east and see the sunset in the flat Earth position on sunset.
You can't see what?
You cannot go east and see the sunset in the flat Earth position on sunset.
Why would you go east to see the sunset when it sets in the west?
Peter Cranston says, how can anyone debate or falsify a model if you don't have one yourself? I take it as dishonest and misunderstanding of science and physics.
Yeah, falsification is independent of replacement. Any intellectual form would laugh you out of the room if you think I need to replace it prior to my falsification being valid. You made the positive claim void of empirical evidence. We have falsified it. We don't have access to all the empirical evidence to formulate a model, so it would be intellectually dishonest to do so. I would be doing what you're doing, which got us in this mess. So again, if someone tells me Santa's real, I then find my parents are giving me the gifts under the Christmas tree. I don't have to come up with a new Santa, a new character from the North Pole before Santa's not real. We falsified your model, bro. Don't make this weird. The Earth is flat.
You never did.
The only model that Flat Earth has is me. So,
this one coming in from do appreciate your question. Nephilim Free says learn from pro photographer trained by NYI, the New York Institute of I think it was lighting, or they say light refracts at an angle equal to its incidence. This is photography and physics science.
Really? Are light rays real, or are they just unrealistic ideals that we utilize, assuming that the terra firma is actually breathing in and out effectively with the category air? How is this even somewhat relevant to assuming that the horizon's moving but not moving and the Earth's a ball and there's no horizontal boundary, which is the requirement of the phenomena of refraction? So cool, you use cameras, bro. Earth must be a ball.
You got it, and thank you very much for your question coming in from John Rapp says, observations, Wittsit is king of clowns.
Whoa, bro. The Earth really is a ball, huh?
Yeah.
Wow. Okay.
Luke Filewalker says, I live in a valley where there's no reception from an Earth-based radio/TV tower. Where does my satellite TV come from?
Well, NASA admits on their website that they put all kinds of satelloons up and buy 90% of the world's helium, and they're number one purchaser of helium in the world. So you tell me.
You got it, and thank you very much for your question. This one coming in from Tim Pryor. Good to see you. Tim says this. I missed this one. Was there any actual flat Earth evidence, or was it all talking about the globe?
No, we
talking about the globe.
Talking about the globe.
The globe gets interrupted.
I gave them chance. They
There's
turned
no
it
double
down.
standard here going on.
They
but
said
anyway.
that they wouldn't say that the Earth is flat.
Yeah,
They said it's not a positive.
Carissa?
No, this question was for us.
Yeah.
Oh, what?
They asked specifically, you were the object of the question. This question was open-ended, right? So why are you interrupting a woman?
Evidence, and then you guys just went on your little...
Why are you interrupting a woman, sir? Go ahead.
You look dumb. So they asked
You're the one who started it with the info. I'm sorry you can handle when you dish out.
This one coming in from Brian League says, it is easy to demonstrate a pressure gradient inside containment. Can globers demonstrate pressure without containment?
Yes. Dwayne Kellum has a very nice video where he has a barometer on the balloon. Our claim is that there is a pressure differential. You can see that pressure differential, and there is no physical barrier between the bottom of that flight and the top of that flight.
You got it, and thank you very much for your question. Coming in from Davey Duarte. Davey, oh boy. He starts off in his regular friendly self saying, Mick Baltard, why doesn't the sun start to get obstructed by the fairy tale quote-unquote geometric horizon, unquote, only 3 miles in front of you at a 6-foot observer height?
Why doesn't the sun get obstructed? Well, the sun does get obstructed, and I don't understand why he's talking about that particular horizon distance there. It doesn't really impact the sunset.
You got it. And this one coming in from Sunflower says, Carissa, why would you ever wager your soul on the Earth being a sphere? That's the definition of all risk, no reward.
Because I'm positive? We've known it for like over 2,000
You don't even know
years.
your own model, girlfriend. But
What are you
You-
talking
You don't
about?
have a model. You don't have a model.
I said you don't even
you
know-
lost before it started.
No,
Kai.
no,
You don't have a
know-
model.
We don't need a model.
Yeah, you do.
No, we
You
don't.
absolutely
Don't
need a
listen to
model.
What Wittsit said.
No, I don't care what he said. He's wrong. You need a
I
model.
had to educate Carissa on what kind of gravity she's talking about.
What are you
No,
talking about? I
no,
said
you had
gravity
to-
acts as
To
a
show you
force.
don't understand
Stop.
stuff.
I won't engage. I won't engage. It's
This
okay.
one coming in from King Ed V said, quote, I said radar, not... Oh, this is for Wittsit. We got to wait until Wittsit gets back.
He's coming.
Fat Man says, that's also for Wittsit. Robert Summers, it's all for, okay, let's see. Seamage Play says, Wittsit, does Nathan know you're cheating on him? Next up, this one coming in from Fat Man says, no, Wittsit, we don't come to see you. We come to see MCToon. Don't flat hard yourself. This is coming in from Robert Summers. Says, so Wittsit, you don't hold your own positions to what you ask from the Globers. Didn't manipulate a variable, but accept the experiment.
I was kidding. Yeah, we can control the variable of water always finding its level. We control the variable of the necessary antecedent gas pressure being containment. We can actually physically measure the Earth, and we falsified the radius. You cannot in any way control any variables of your causal agents. So just try again.
This one coming in from King Ed V says, I said radar, not radio, Wittsit. I was a hard horizon that never changes. Or they said, I has a hard horizon that never, what was it?
It has a hard horizon.
Thank you. It has a hard horizon that never changes, and it comes up with the right radius of Earth. P.S. I'm an ex-Navy radar operator.
Wow. How come radars have to assume that the Earth is flat for the word with electromagnetic propagation over a flat Earth whenever the military says it themselves? And is the hard horizon consistent?
Deflect.
In all locations? No, it's not a deflect. It's not consistent. And it fluctuates based on the location. It fluctuates based on location. And the U.S. military declassified document of electromagnetic propagation over a flat Earth has to assume the Earth is flat to use the ground weapon system.
You didn't read that.
You should have listened.
Read it. You should read it.
This one coming in from
McToon, there's the ball.
Made by Jim Bob says, Toon. Regarding space-time, time is a conceptual tool we use to measure change. How can a concept be bent? What physical properties does a concept have?
Space-time is not space plus time, and they're separate things. Austin says it all the time, demonstrating that he does not understand the concept at all. It's not that space-time is wrong. It's that he doesn't understand it.
Yep, cool story.
You got it. This one coming in from David Villar says, you cannot see the sun set in the flat Earth position when looking westward.
That's when the sun always sets, is looking westward, bro. Where have you been, dude? You think we're falling backwards 1,000 miles per hour during a sunset, and it just makes the sun look like it's moving, but it's actually sitting still. I'm the conspiracy.
What they meant to say, well, this is because they originally put... They had an earlier super chat that... They said you cannot go west and see the sunset in the flat Earth position on sunset. Then that's okay. I think we got that covered. And then this one coming in from Isaiah 40:22 says, Nathan, do you believe for those who believe in theoretical science, is it a salvation issue? Wittsit, I think they just called you Nathan.
Oh,
yeah.
I'm sorry. I'm not familiar with who that is. So next.
This one from Really Though says, can the globe side explain how it's possible to see both the moon and the sun in the sky at the same time, all while the moon has a quote unquote shadow on it?
Yes. It's not hard.
Space.com says celestial geometry cannot explain why this happens. They can't. It's impossible.
Interesting.
So I'd love to see the citation on that.
I'd love to hear your explanation since you disagree.
I'll pull it up. Just give me 1 second.
Crickets.
Isaiah 40:22 says, they say, for the flat side, do you believe, for those who believe in theoretical science, is it a salvation issue?
I would not say that thinking the Earth's a magic spinning cartoon ball that defies physics in a vacuum brought to you by Jesuit speech where everything comes from nothing but nothing, there's pre-existing energy, but I digress, is a salvation issue. No, he examines your heart. But hey, if you don't know the earthly things, how can you know the heavenly things? And Hosea 4:6, my people are destroyed for lack of knowledge. So I don't know. I would be interested in the truth. That's the most important thing.
And for McToon, here's the source. This is from space.com. The little used name for this effect is called a selenilian, a phenomenon that celestial geometry says cannot happen. There you go, sir.
Yeah, take that out of context. Excellent.
Oh, just run away.
Just let him say.
You got this one coming in from Made by Jim Bob says, Toon, what is one physical property of space-time such that it can be bent?
This is not the place for a relativity lecture. Go watch those. And if you'd like to come to my channel, maybe we could discuss it sometime.
This one from Thank the Most High God says, MCToon, if the sun and moon won't be seen when I see them both, is other side of Earth. Gosh. It's okay if you guys want to do me a solid when you submit a question. If you want to proof check it. So they say, MCToon, if the sun and moon won't be seen when I see them both, is other side of Earth is in complete darkness, and post video of 1,000 miles per hour ball you have.
I don't understand what he's talking about there. That maybe we could get some cryptographers to decode that. On my channel is a video of the Earth spinning, a couple different ones. You can find it.
I think if I can take a stab at it, I think what he's saying is that if you can see both the sun and the moon in the sky at the same time, is there no light on the other side, which would be the case. Because the moon revolves around the sun. I'm sorry, the moon revolves around the Earth. And therefore, there are, and I think it's like 29 days it takes. So there are times where, there are definitely times where you have a full moon and then you have a new moon, right? So there are times where you don't have any light in the sky. So yes, that's not a problem for the globe perspective.
You got it. Thank you very much for this question coming in from David Villar. Says, one more time, you look westward during sunset. The flat Earth sun will be too far north. Please put me on the debate. Texting blows.
Oh, okay. If you're wanting to debate me with me, man, I'm gonna need some subs, man. I can't. But yeah, if you got some subs, but yeah, it actually does seem to go not exactly west. You should look into it, right? It doesn't go exactly west. But once again, the Glober says that during a sunset, we're actually falling backwards 1,000 miles per hour. And it just looks like it's moving when it's actually sitting still. I'm going to pass on that one. Hard pass from the boy.
This one coming in. And folks, we don't have enough time for any more questions, so please don't send in any more. We got to get this wrapped up soon. Ariel Fernandez says, Kai, do you believe that it's winter season and not summer season in the northern hemisphere when the northern hemisphere is tilted towards the sun?
Sorry, was that for us or was that?
Yes. They say, Kai, do you believe that it's winter season and not summer season in the northern hemisphere when the northern hemisphere is tilted towards the sun?
When it's tilted towards the sun?
Correct.
What season is it?
Correct.
It is winter. It's
summer.
It's summer, but when it's closest, when it's
you're right.
I asked you.
You're right. You're right. It is.
We know.
Yes.
You were
yes,
right.
Because you were going on.
Hold on. It's not because it's closer that it's hotter. It's because of the light being diffused
yes, but you can't
along the surface. But yes, I was wrong. You were right. Hold on. You were right that because it's an ellipse, it is still slightly closer when it is winter, but the light is diffused over a bigger space.
Thank you for being honest after you Googled it. Yes. Thank you.
But yes, when the northern hemisphere is pointed toward the sun, it is 100% summer.
The reason I brought that up though is you were talking about how seasons make no sense on a flat Earth.
No.
It makes no sense on a globe that when you would be furthest.
No, that's not our claim.
Summer.
It's the tilt, not the distance. That's the cause. That's another just misunderstanding.
Also, I'm not saying I'm just to clarify, I didn't say that it was just the seasons that were inconsistent on your part. It was the seasons along with the daylight.
Yeah, Earth
so in Antarctica, and then in the southern hemisphere, and not just Antarctica, I'm talking about even like South Africa, they have really long like days, and then in Alaska they have really short days. So that's not consistent along with the seasons. That was my point.
Gotcha. Coffee cup caustic.
It makes so much more sense with a small local sun than a large.
It still doesn't make sense.
Okay. Cool.
Great.
Coffee cup
So when you're
caustic.
furthest from the sun, it is summer.
You should look up coffee cup caustic. Next.
You got it. Thank you very much for this person. Chad Martin says, to be more specific, why do stars rotate clockwise in the southern hemisphere and counterclockwise in the northern hemisphere?
Actually, you can demonstrate this with a dome as well. Like you can have some type of a dome container to actually create the illusion of that. So there you go. There are numerous different ways. And of course, that's non sequitur to the fact we measure the surface of the earth. So
this one coming in from Wittsit Ky says, how can space-time have physical properties if it's just conceptual, Carissa?
I was trolling.
So I honestly do not understand space-time to a full extent. I think that's not something I've studied very much. I understand. I think McToon would be a better person to ask, so I yield my time.
But he didn't answer either, so that's why I asked you. But I was just sorry. I was trolling.
We can't do that lecture here.
Yeah,
It's not nearly enough time here.
James, sorry, I tried to add you and say I was just joking, man. Anyway, they don't know. There's no answer. It's no big deal.
John Rapp says, Kai, this is the last question of the night. Thanks, folks, for your questions. Says, Kai, what was your Bachelor of Science degrees major?
Behavioral.
Like psychology?
Behavioral science.
Interesting. And want to let you know, folks, our guests are linked in the description. We do appreciate our guests. Want to remind you, attack the arguments instead of the person, as we really do appreciate our guests. And we're okay with like friendly, like playful teasing. That's not a problem, folks. Like we don't want you to feel like you're walking on eggshells. But at the same time, when we have like super personal stuff, or like last night we had somebody trying to, what's the word they use for that? Dox. That kind of stuff is we're like we don't need it. So want to let you know, we really do appreciate our guests. They're linked in the description right now, folks, including if you're listening via the podcast, as all of our debates end up on the podcast within 24 hours. We put MCToon's and Carissa's and Witsit's links in the description box for the podcast as well. So if you want, you can click right now. You can find their channel and all that good stuff. And so we do want to say thanks so much for all of our guests being with us tonight. Carissa, MCToon, Wittsit, and Kai, it's been a true pleasure.
Thank you, bro. Much love.
Thank you.
My pleasure. And I'll be back in just a moment, folks, with some juicy announcements about upcoming debates. And still pinned at the top of the chat is that sign-up sheet if you want to come on and debate topics such as this one. I will be back in just a moment, so stick around.